Hi, and a very good morning. Ladies and gentlemen, the event is about to begin. Welcome to the first day of the fourth International Symposium on Agents, Multi-Agent Systems and Robotics 2021, as we all know it as Isamsr 2021. Kindly take note of these housekeeping rules. First of all, turn off or silence your phone. If you're connecting on your computer, close down all other apps and browser windows to eliminate notifications. Mute your microphone when you are not speaking. During the Q&A session, do use the pigeonhole to type your questions accordingly. So ladies and gentlemen, without further delay, good morning and welcome again. Let's start the event with the first keynote speech. We have the pleasure to have Professor Dr. Michael Woolrich from the University of Oxford to share his research foresight with all of us here today.
It's Mike Wooldridge. I'm a professor at the University of Oxford, and today what I'm going to talk to you about is understanding equilibria in multi-agent systems. So let's kick off by giving a little overview of the talk. What I'm going to start off by doing is very naturally motivating the idea of what we want to do, which is to do with trying to understand the possible behaviours of multi-agent system, and that's going to lead me into an idea that we've been investigating over the past decade at the University of Oxford called rational verification. And this is bringing together techniques from game theory and from automated verification to be used to understand the equilibrium properties of multi-agent systems. Then I'm going to talk about a very specific framework that we've investigated called reactive modules games, and a tool that we've developed, that our DPhil students have developed for being able to verify the properties of multi-agent systems using this framework. And then I'm going to talk about a different approach to understanding equilibrium properties of multi-agent systems called agent-based modeling. So first, we're interested in multi-agent systems. So what are multi-agent systems? Well, the first thing to say is multi-agent systems finally happens. So what do I mean by that? Well, 30 years ago, many of us in the AI community had the dream of what are called software agents. And the idea of software agents is that most computer applications that we work with are essentially passive. When you use Microsoft Word or PowerPoint, it is essentially a passive system that's waiting to be told what to do. And everything that happens on the system happens because you make it happen. So the idea of what are called software agents was, instead of having software as an essentially passive thing, what you want to do is to have software as an active assistant, something which is working with you on the tasks that you are working on, something which is working with you in the same way that a human expert or a human expert assistant would work with you. So lifting software from just being the dumb recipient of our instructions to being an active assistant, something which is cooperating with us to solve our problems. And that dream of agents took some time to happen. I mean, the original vision dates back to the late 1980s, but it began to be mainstream with the introduction of systems like Alexa and Cortana and Siri on our smartphones. And now we all carry around with us an agent, and it's a direct descendant of that dream that we had in the late 1980s of systems which work with us as active assistants that are not just waiting to be told what to do, but are actually actively working with us. But there was one part of the picture which we thought was inevitable at the time in the late 1980s, which didn't quite come to happen in the way that we anticipated. What we anticipated is that by the time we were carrying Siri and Alexa and Cortana around with us in our pockets on our mobile phones, that Siri and Alexa and Cortana would be talking to each other. And that is the dream of multi-agent systems. Well, it hasn't quite happened that way yet, although I think we will. Actually, it seems very natural to think that in the future that these software agents will interact with other software agents, just as they interact with people. But nevertheless, multi-agent systems, the idea of AI systems talking to other AI systems, that's what multi-agent systems are, AI systems that are interacting with one another, are in existence today. So for example, high frequency or algorithmic trading systems. Most of the trading that's done on the global markets is done via algorithmic trading systems. These are computer programs, agents, very often with AI technology, which are busy buying and selling things on the global market without any human intervention or control or oversight whatsoever. So multi-agent systems do exist today, not necessarily the way that we originally anticipated that they would exist. But one of the things that we've discovered is that multi-agent systems have very often unpredictable dynamics. So if we look at the global markets, you can see examples essentially of where multi-agent systems have gone wrong. So one example was the October 1987 market crash. Why did the October 1987 market crash, which was called Black Monday or Black Wednesday or something, Black someday or other, why did it happen? Well, one of the reasons that it happened was the increasing use of what were at the time very simple automated trading systems. And what happens when you have such systems is that if they are all programmed in the same way, if typical rule would be if the price of a particular stock starts to go down, then you sell that stock. Well, that creates feedback loops, because if you if the price of some particular stock starts going down and all these trading programs see that and then start to sell stock when they see the price going down, then that generates a feedback loop because it pushes the prices even lower, and so more programs start to sell that stock and so on. Now, that's by no means the only reason for the October 1987 market crash, but it's one of the reasons. More recently, much more recently, a decade ago, we saw the May 2010 flash crash, and this is over a 30-minute period. The Dow Jones lost over $1 trillion in value over 30 minutes. The joke was, if you went for a coffee, then you missed it all, and then it bounced back up. It wobbled quite substantially when the prices went back up, but they bounced back up. So why did that happen? There were many reasons. It's a complex event, but one of them is certainly the use of automated trading programs. It would literally have, the flash crash would literally have been impossible without automated trading programs that are trading on tiny, minute timescales. So this is what the flash crash looked like. This is the Dow Jones Industrial Average over 6th May 2010. And you'll notice at around 2:30 in the afternoon, there's a massive collapse, massive and very sudden collapse in market value, and then in the space of 15-20 minutes the market bounces back up again. So very scary event on the global markets, and governments and banks and regulatory authorities very concerned about that. So you've got the global marketplaces, which are a huge multi-agent system, and we've got evidence that this huge multi-agent system can be prone to unpredictable and very scary dynamics. So in a nutshell, what we want to do is we want to try to understand and manage multi-agent system dynamics. And how do we do that? We want to be able to identify when we're building a multi-agent system, a collection of interacting AI agents, we want to be able to identify the possible behaviors and trajectories that multi-agent system might exhibit. And we want to understand when this might be damaging or dangerous, and we want to be able to try and manage it. So how do we do that? Well, we adopt two approaches in our work. The first approach that we adopt is we treat the flash crash as a bug. It's a bug in the system. It's a bug in the global marketplaces. And to try to deal with it, we use ideas from verification and from game theory. Right? And I'll explain how that works in a moment. The second approach is completely different. What we do in the second approach is we model the system directly, and we use a technique called agent-based modeling. And in agent-based modeling, what you do is you model all the decision makers in a system. So you literally model a trading system down at the level of individual traders, and you simulate what goes on in the markets, and you use those simulations, typically with Monte Carlo simulations using random variables models to drive the simulations for a range of parameters to try and understand what's happening. So these are the two approaches that I'm going to talk about. I'm mainly going to focus on the first approach, but I'll also mention the second approach. So the first approach then, we treat the flash crash as a bug, and we use the technology and the science that's being developed within computer science to identify bugs in programs, and we bring all that to bear. And the most successful approach for dealing with bugs in this way is what's called model checking. So here's how model checking works. The basic idea is, in model checking, is that you're given a particular computer program P, so think of that as your Java or Python program. What you can do is, if you look at the state transition graph of that program, right, you can view that state transition graph as what's called a model for temporal logic. That is, the state transition graph identifies all the possible states of the program, and it connects two states together if the program could execute an instruction to transform from one state into another. Now, that state transition graph can very naturally be viewed as a model for temporal logic. Temporal logic is a language for talking about state sequences, for talking about the temporal ordering of events. So what we can do with temporal logic is we can express properties like we never have a flash crash as a formula phi of temporal logic. And then checking that the program satisfies its specification, is correct with respect to its specification, boils down to checking that that property, that temporal logic property, is true in the state transition graph when interpreted over that state transition graph. And this is the notation that we use for model checking problems. This just means that this property phi is true, my system never has a flash crash, is true in the model that represents my trading system. Okay, and the point is that checking process, checking that formula is true in the model, can be quite efficiently automated in many, many settings. And so there are now many industrial strength model checking systems available. The most widely used language, and the one that we're going to use in this lecture, is called linear temporal logic, which is abbreviated to LTL. And I'll explain what that language looks like and how you might use it to express the properties of your systems. So let's just look at what this picture looks like. This is the picture of model checking. And in model checking, we have our state transition graph. So remember, these nodes in this graph correspond to the possible states of the program, and the edges correspond to transitions corresponding to the execution of individual program instructions. And that leads us into this state transition graph, and each path through this state transition graph corresponds to a possible execution or run of your system. So think of that as this state transition graph is then encoding all the possible behaviors of the system that you're interested in. And then you've got the property that you want to check. So this is a particular, don't worry about what this one means. It's just expressed in this language LTL, which I'll come on to in a moment. And what a model checking program will do is it will check whether this particular property on the right is true of the model that we give as an input on the left there. And it will say, yes, that claim is true, or no, it is not true, right? It satisfies this claim or it doesn't satisfy this claim. So let's introduce our language LTL. And it's a language for talking about infinite state sequences. Typically we stick with propositional languages. So these languages extend propositional logic. So we've got the usual connectives of propositional logic, primitive propositions, negation, disjunction. But then we've got, at the bottom, we've got these funny symbols, these what are called temporal operators. So the circle operator means in the next state. So we're talking about languages for talking about state sequences. And what this property means, circle phi means, is that phi is true in the next state along on the state sequence. The diamond means eventually, that means it's true on some state sequence if phi is true eventually at some point in the future on that state sequence. The box phi means that phi is always true, right? That it's true on every state in that state sequence. And finally, phi until psi means that phi remains true on that state sequence until the point in the future where psi becomes true. So let's have a look at some actual formulas. Remember, the diamond means at some point in the future. So this property means eventually I will not have jet lag, right? So this is the regular negation, and jet lag just refers to the states where I have jet lag. So this just says I will not have jet lag. Okay, this property means, remember, the box means in all the states that we reach. This says in all the states we reach, we will not crash. So think of crash here as just being a primitive proposition which refers to a flash crash. So this just says, this is what's called a safety property, and it says on all the states in the sequence, in this particular computation, we don't have a flash crash. We can combine these operators. So if we combine them box and then diamond, what we get is an operator which says that something will happen infinitely often. So it's always the case, no matter where you go on this state sequence, that there will be a subsequent point on drinking beer where drink beer is true. What that means is I will drink beer infinitely often. If we flip them around, the other way around, the diamond box, what that means is that eventually we will reach a point on the state sequence where you're always dead is true subsequently afterwards. So what that means then is that eventually there will come a point after which I am dead forever. And then finally, this binary operator, the until operator, not friends until apologize you, means we are not friends until you apologize. There is some future state at which you apologize, and all the points until then, all the points on the state sequence until then, we are not friends. So we're not friends until you apologize. We're not friends until you apologize. So that you operator means until. Okay, so model checking with LTL, where you give your system as an input and a query expressed using the language that I've just described, linear temporal logic. This is what's called p-space complete. This problem is p-space complete. And given that model checking setup, there are usually two questions that we want to answer. One is called reachability and the other is called invariance. So the reachability question says, is there some computation of the system on which phi eventually holds? Whereas the invariance question says, does phi hold on all possible computations of the system? So in other words, reachability says, is there at least one path through that state transition graph on which this temporal property is true? And invariance says, is it true on all possible paths through the state transition graph? Okay, so there are a whole bunch of assumptions built into this model. This is a very common model in computer science. It's been very widely studied, but it includes a large number of assumptions. One of them is that basically there is just one standard of correctness. There is one property phi that we want to check, and the system is correct if it satisfies it and incorrect otherwise. And so that there is just one person who enjoys what's called a privileged position here, who's able to say this program is correct or not correct. Well, this doesn't really make sense for many systems. I mean, it doesn't make sense to talk about whether the internet is correct or incorrect. It contains huge numbers of interacting agents. Some of them are people and some of them are pieces of software. And each of those agents is trying to do the best for themselves. So we need an alternative perspective to try to be able to talk about those systems. To illustrate this, I'm going to just use this example from robotics. Here we've got, think of this as being a warehouse scenario, and we've got two robots on the top left and the bottom right, and the robot on the top left must visit the location on the bottom right and then return and just keep doing that. So it's servicing those two locations, just transporting things between them. The robot on the bottom right has to do the opposite. It just has to visit the top left and then go back and back and keep doing that. Okay, so one way to think about this, and this is a very classic AI way of thinking about it, is suppose you're the robot on the bottom right. Can I achieve my goal? Can I, on my own, guarantee to get my goal achieved? Well, the answer is no, because the other robot could just block your path. The robot could go in the middle in this doorway here and block the path, and that would completely prevent the robot in the bottom right from getting its goal achieved. But there is an alternative perspective where they can. And that's if we adopt what's called a game theoretic perspective. And if we think about what are called the equilibrium behaviors of this system, there are some equilibrium behaviors in which they can get their goal achieved. So here's how it works. So imagine that this robot on the top left just gets out of the way, and then the robot on the bottom right services that location, and then it itself gets out of the way, and then the robot from the top comes in, services that location and goes back. This robot goes back, and then they just repeat that behavior. Now, technically, that's what's called an equilibrium behavior because neither agent can do any better. They both get their goal achieved, so they're both completely happy with that. If you just adopt the perspective of thinking, can I get my goal achieved on my own, you miss that possibility. So this is what's called rational verification. And in rational verification, what we do is we adopt a game theoretic standpoint for understanding this system. We assume that the agents in it are rational actors and that they are trying to do the best that they possibly can do to try to bring about their preferences. And the way that we analyze the system is using what's called solution concepts from game theory. And the most important one of those is what's called Nash equilibrium. And what Nash equilibrium means is it means behaviors for each of the participants where all of them are satisfied that they are doing the best that they can, assuming that the other agents stay with their behaviors. That's what a Nash equilibrium is. Now, in that setting, if we think about a system in that way, then we get some interesting analogues of the ideas of reachability and invariance. So remember, reachability says, is there some way that my system could behave which would make this property true? And invariance says, will it inevitably be true within my system? Well, if we bring this game theoretic perspective in, we get a different view. And the different view is that we talk about Nash reachability and Nash invariance. Nash reachability says, is there some way that this behavior could be true under the assumption that the agents act rationally? In particular, by choosing Nash equilibrium strategies. So Nash reachability says, is there some way that this particular property could be true under the assumption that the agents act rationally? Right? That's Nash reachability. And Nash invariance says, is it inevitable that this property will be true under the assumption that the agents act rationally? So now then, this is what our picture of rational verification looks like. We've still got our model of the system. It's probably a bit more complicated because it's got multiple agents in it that are all able to act independently. There's the property that we want to check. Is this property true of my system? Is it going to have a flash crash? But the third input now to be able to answer questions like Nash reachability and Nash invariance is the player preferences. We need to know what each of the agents prefers. Okay, and then our rational model checker will say either yes, this property is true under the assumption that it can be true under the assumption that the agents choose a Nash equilibrium, or no, it is not true under the assumption that they choose a Nash equilibrium. Okay, so that's the general framework. So let's talk about a very specific scenario that we've looked at called reactive module games to investigate this, right? And this reactive module games is a very particular, a specific instantiation of this framework of rational verification. So the idea is that we use what's called a language called reactive modules for expressing the properties of a multi-agent systems. And technically it's what's called a guarded command language. Guarded command languages are quite widely used in theoretical computer science, but think of it as being a rule-based language. And it was introduced about 20 years ago, and it's now very widely used. So let's just jump right in and look at how we define an agent in the reactive modules framework. So this is a particular example of an agent defined using reactive modules. So the first thing you'll see is that the agent, and they're called modules in reactive modules, the agent has a name, and here the name is toggle, and it's called toggle because what this agent is going to do, it's got a very dumb behavior, it's just going to toggle the value of a variable on and off. And we specify the variables that it controls, and here it controls the variable x. But controlling a variable means is that this is the only agent which is allowed to do anything to variable x. And then the behavior of the agent is defined by rules. And we've got two classes of rules. We've got init rules, which stands for initialization, and update rules. And update rules are rules which define how the variable changes, how the agent changes its variables over time. Okay, this funny box symbol here is just a syntactic separator, so just read that as just a syntactic separator like a semicolon. And then we've got these rules. So this first rule, the condition on the left is just true, and it says, okay, if the condition on the left is true, then I'm allowed to do the action on the right. And what the action on the right here says is set the variable x to be true. So the x prime notation means that the value of the variable x afterwards is set to be true. So we've got two initialization rules, one which says if the condition is true, then I'm allowed to set x to be true. Alternatively, if the condition is true, I'm allowed to set x to be false. What that means is the way that this agent is allowed to initialize its variables is to choose one of those two rules. It's going to have two rules which are available for initialization, and it's going to be able to set x to be true or x to be false. Once it's done that initialization, it then uses its update rules. And these rules say, well, if x is true, then I set x to be false. And if x is false, then I set x to be true. So in sum, what this agent is going to do is it's going to start by just non-deterministically choosing a value for the variable x, and then it's just going to subsequently flip that value. If it was true, it becomes false. If it was false, it becomes true. So this is a nice simple language, and in the condition parts of these rules, you can have any condition over the variables in the whole system, so potentially variables that are controlled by other agents. And it's a Turing complete language, so if given enough resources, you can simulate a Turing machine with these agents, and it's a nice, simple, elegant language for modeling multi-agent systems. So a little bit more formally then, what we call an arena, we call it an arena because it's where a game is played, just consists of a set of agents, a set of Boolean variables, these are all the variables in the system, and then a set of these modules, which are the agents in the system. And each module consists of the variables that that module controls, its initialization rules, and its update rules in exactly the same way that we defined earlier. Now, we need the notion of what's called a strategy in one of these games. And a strategy just defines how a player makes choices over time. And what we do is we model strategies as finite state machines. How do we model preferences in these settings? We model preferences by giving each player a temporal logic goal that it wants to see satisfied. So, drink beer infinitely often might be an example of a goal in exactly the language that we talked about earlier, the LTL language that we talked about earlier. That would be an example of a goal for one of these frameworks. So an arena specifies the agents in the system and the actions that they can perform via their initialization and their update rules. And then each agent has a temporal logic goal which it wants to try to accomplish. Okay, so there's a technical definition that I'm not going to go into, but basically we've got a strategy for an agent is going to tell it how to select its initialization and update rules. In other words, how its behavior of an agent unfolds over time. And a collection of strategies, a strategy profile, one for each agent, is what's called a Nash equilibrium if no player regrets their choice given the choices of others. And given a particular game G, where the game G consists of the arena and the LTL formulas for each of the players, any of G will denote the Nash equilibrium of a particular game. So let's dig straight into some computational problems. Here's a very natural problem. You're given a particular game G, you're given a profile of strategies. So this is a bunch of finite state machines which are going to tell the agents how to choose their initialization and update rules. And you're given an LTL formula phi. Is it the case that that property phi would result on the run that you get by those agents jointly executing their strategies? So this notation rho of vex sigma here just means the run that would result from the agents executing their strategies vex sigma. So would phi hold under the assumption that those strategies were jointly executed? The membership question, we're given a game G and we're given a strategy profile, and we're asked now a game theoretic question. Is that a Nash equilibrium strategy profile? Well, The first result is that our model checking problem is p-space complete. That's not too surprising because we know that the regular model checking problem for LTL is p-space complete. But the second one is a bit more surprising because this is a game theoretic question. It turns out that it's no harder than the model checking problem. It's also p-space complete. So far, this is quite good news. Things are no worse so far than they are in the regular model checking case. But now we move on to some more complex questions. The E-Nash, A-Nash and non-emptiness questions. The E-Nash question says, is there some profile of strategies which form a Nash equilibrium such that if the players chose those, in other words, if they made a rational choice and chose those strategies, phi would become true? The A-Nash problem says, would phi become true for all Nash equilibria that our agents could choose? And then finally, the non-emptiness question is, does a game have any Nash equilibrium? Well, here we get a rapid blow up in complexity. These problems blow up to what's called 2x time complete. So these are computationally hard problems. And when you encounter 2x time completeness, what that tells you is you're going to need to look at special cases for these problems, or you're going to need you're going to need to look at special cases for these questions, or you're going to need to look at approximations of them or simplified cases. This is just a picture now of what we're trying to do. We've got our multi-agent system on the left defined using the reactive modules language. We've got our goals for all of our agents, and then we've got the query that we want to check. Think of that as, is there a flash crash? And what our rational model checker is going to say is either, yes, this claim is true on some Nash equilibrium, that is, it could happen under the assumption that the agents made rational choices, or no, the claim couldn't happen for any collection of rational choices. Now, we've implemented this framework using the Eve system, and you can find the URL on the slide there, eve.cs.ox.ac.uk. I'm not going to go through the algorithmics of it. They're quite technical. Suffice to say, it uses a bunch of automata theoretic techniques, but you can contact Mohammed Najib, who did this work for his PhD, and he will be happy to tell you about the Eve system. But it implements exactly the questions that we talked about. Just finally, for 1 minute, I'm just going to briefly sketch an alternative approach. And the alternative approach is what's called agent-based modeling. So remember, our original motivation is to be able to study scenarios like flash crash scenarios. Well, the truth is, the approach that I've just described is not going to scale to modeling flash crash scenarios. It's just the systems that we're looking at are going to contain millions of agents. 2x time completeness results tell you that there's no way you're going to succeed in making that scale to millions of agents. So what can you do instead? Well, agent-based models, agent-based simulation says what you do is you simulate the system. You simulate the system down at the level of individual decision makers. Okay, which means in flash crash scenarios, you model the system down at the level of the individual traders. And this is possible to do now. It's a very old idea, but it's possible to do now because of the availability of big compute power and data to populate these models. And so we've done work, and this is James Paulin in his DFilthy student. He's done work on understanding flash crash scenarios by modeling them down at the level of individual decision makers using real world data, about which companies are buying which stocks and so on. It involves millions of agents, lots of computational time, lots of real world data. And using that, you can start to draw conclusions about what happens in flash crash scenarios. So I won't go into the details of one of these, but just for example, one of them is that relates to what's called crowding. So the idea of crowding is that where you've got lots of different traders that are all investing in a particular stock, let's call it Apple. Now, crowding is generally understood as being dangerous in flash crash scenarios because if we're all investing in the same stock and that stock becomes distressed and its price starts to go down, that's going to affect all of us. We're all going to be in trouble as a consequence of that. Oh, sort of slightly surprisingly, James discovered that although it can be dangerous, he also found that actually there are some cases where it can actually be beneficial to systemic stability. Okay, so in this talk, what I've been looking at is understanding the dynamics of multi-agent systems, and I've sketched out two different ways that you can do that. One is a very formal analytical approach, which involves treating things like flash crashes as bugs in a program and applying the technology that we've developed, the science and technology in computer science that we've developed to understand and find bugs, in particular model checking, to analyze these systems. And we've taken ideas from game theory to be able to do that. The other approach, which I very briefly sketched out, is to model the system directly and run simulations on that system. Very briefly, we're just starting a new project at Oxford, which is going to be trying to bring these two approaches together. So we want to try and bring agent-based modeling and rational verification closer together. But that's future work, and I hope to be able to describe it to you in future editions of this conference. Thank you for your time.
Thank you very much, Professor Dr. Michael Rich. And ladies and gentlemen, welcome back. We will move on to our second keynote speech today. So let's welcome Professor Dr. Marcin Paprzycki from the Systems Research Institute, Polish Academy of Science.
Hello. It is my pleasure to be here, even though it is only by video. My name is Marcin Paprzycki, as you will see from the first slide in a moment. I have been invited to share some thoughts with you in the context of fourth international conference on agents, agent systems, and robotics. I wish I was right now in Malaysia with you and would be delivering this talk in person. However, with the time differences and with the COVID, this was the only way to communicate with you. So I apologize. By the way, my camera is here, but my big screen is that way. So I may be sometimes showing just side of my face when I'm going to be doing something on the big screen. So I apologize for this, but this was the only setup I could come up with. So let me start with sharing my screen, and here you should slideshow. Okay, so now you should see my first screen. So what I wanted to share with you today is some thoughts about the state of the agent systems world in the year 2021 from a very practical perspective. Once more, my name is Marcin Paprzycki, and I work for the Systems Research Institute, Polish Academy of Sciences, and I collaborate with Professor Maria Ganja, and I also co-teach with her a course on software agents at the Warsaw University of Technology every year, every spring. So let's move on and let's get to work. A lot of thoughts that I'm going to share with you should be obvious to you, but I hope that the way I put this all together may be of interest to you and may lead you to some thinking. So we have internet everywhere, which is obvious, but this means that everywhere within the internet, you have what I name computational resources, resources that can process things, and data resources. And by the way, even the simplest phone that each and every one of you has, a smartphone, most likely is a computational and data resource. This means that everything is now mobile. Mobile means that some of you may be taking my talk and listen to the video while in the living room or in your study, and then go to the kitchen to get more coffee and come back. And in the meantime, I am all the time talking to you. This is mobility. We also live in the era of very cheap sensors and actuators, and they put together, when they are put together, they allow creation of the Internet of Things, so-called, and this brings data deluge, which means that there are zillions of data sources that are generating data streams. And the data streams are flowing from edge, where they are created, through fog, which is the intermediate, all the infrastructure of gateways, maybe some additional servers, local servers. Someplace there is likely to be a central cloud. So we have the edge fog cloud continuum. This brings about big data analytics, big because there is so much data which is generated by sensors. And think about this, each smartphone has around 10, 12, 13, 14 sensors on board, and they are constantly generating data. This is just an example. So we have those streams that are flowing and flowing, and we need to analyze them. Of course, this means that data flows will end up somewhere or will be discarded, and the data will be processed on something. Okay, here you can envision some Raspberry Pis or Arduinos or Movidius sticks or NVIDIA Jetson Nanos as small devices which are everywhere and they process data streams. But if you have so many data streams, you can measure changes. This is the difference. In the past, for instance, if the truck was leaving Penang for Kuala Lumpur, then until it arrived in Kuala Lumpur, you didn't know where it is. Nowadays, you not only know where it is, but you have non-stop updated prediction when this truck will arrive, let's say in Shah Alam, okay? Because let's say that this truck is going actually to Shah Alam, and I hope that I pronounce it right. I was there once, and it's a very nice place, but I may be mispronouncing it, so I sincerely apologize. But let's say it's going there, and you know, with prediction of around 1 minute, 2 minute differential non-stop when it's going to arrive. So when something changes, when there is like a road traffic jam, then you will constantly see how the predicted time is changing. Okay, dynamicity of the environment. This, being able to measure and act, allows us to create smart everything: smart homes, smart factories, smart cities, smart ports, smart cars, smart vacuum cleaners, smart televisions, smart everything, okay, phones. So this means that we have more and more smartness around us. I'm, by the way, not sure if this brings more smartness in people, but people that may not be smart are surrounded by smart equipment, okay? The equipment can be so smart that I have problem with my TV because we don't understand each other. I have this Sony thing, and the Sony thing thinks one thing, and I want it to think something else, and we just don't communicate well. My wife, by the way, is better in communicating with the TV than I am. I'm like, if the TV doesn't like me, and it's so smart that it doesn't like me, okay? Also, everything is heterogeneous because, for instance, if you have a Sony smart TV and you have Philips smart TV, they are different. And whatever you learn about Sony smart TV may not apply to the Philips smart TV. So you have not only legacy systems that are heterogeneous, but current modern systems are heterogeneous, okay? Now, this all brings a lot of asynchronous events that are soft, hard, sometimes softer, sometimes harder, rarely very hard real-time systems, okay? So things happen in some orders, but this is not like you have an algorithm and you know step by step what will happen, because what will happen in one place depending on what happens in the other place, and they're completely independent, okay? The truck that we are talking about that is to arrive to Shah Alam, you don't know when it will arrive. I mean, you constantly can predict when it will arrive, but will it arrive on time or not? It's not something algorithmic, because it depends on somebody doing something crazy on the road between and having an accident, which I don't wish anybody to have, but accidents happen. And then there is a big traffic jam because they have to clean, police have to assess the situation, and so on. So generally speaking, it's very difficult to make sure that things will happen in a predicted order. Now, in this big environment where everything is connected, you can have workflows, and they will involve artifacts located in multiple locations. So the truck will communicate with the factory or the shop or the shopping mall that it has to arrive. When it arrives, it has to authorize its coming, so it will communicate with some authorization center. Then there will be some load that will be downloaded, maybe some load that will be uploaded. It will communicate where to take the next load, and it will start travel there. This means that if your whatever goals are in the system, whatever results are to be achieved, you need interactions, negotiations, coordination, collaboration, agreement formation. All of this has to be done, and outcome of all those interactions depends on sequences of events. But as we just said, events are you are asynchronous, and they influence each other. And it may be that if the same truck starts from Penang and goes to Shah Alam in every week, then in different weeks it will arrive at different times, and it depends on the road conditions. So other events influence the main events in the main pathway of the workflow. Okay. And by the way, a lot of those involve human in the loop. So let's say you are starting some recommender system comes back to you with some suggestions, and until you select something, nothing is happening. So you don't know when the system will do something. So in this world, we also have so-called assistants, and big companies have their assistants. So you have Cortana, you have Bixby. If you have Samsung phone, your Bixby may want to talk to you nonstop. My wife, for instance, she has a Samsung, and Bixby wants to talk to her, and she doesn't want to talk to Bixby. So it's like one-sided relationship. Bixby is in love with my wife, but my wife doesn't like Bixby. Echo, which is Amazon, Google Assistant, Siri. All of you that have Apple phones know how to scream, "Hey Siri," and the Siri will respond to you or not. Maybe other companies are now producing assistants, and assistants are supposed to help us deal with all this asynchronicity, dynamicity, and so on. Okay, fine. But how to survive in such dynamic world? And of course, all of you are here specialists in software agents and agent systems. So you know that my response will be software agents to the rescue. And we are now in the year 2021, and I am coming and saying software agents to the rescue. So I wanted to show you something, and now it's going to be the tricky moment, and I will have to turn to my big screen because I gonna share something else with you. Okay, let's try it. What you now should see is a page from the Cordis, which is like the European Commission archive for all the grants and projects. And Agent Link 3 was the third phase of a coordination network for agent-based computing. And I'm going to give you a moment to read, well, more or less, I want you to read for yourself this area, okay? So I hope, by the way, that you can we make it bigger? Maybe I can make it bigger for you. Okay, I made it bigger for you. So have a look at this, and I will have a sip of tea, okay? So this area, please read it. I hope that you're going to have enough time because I cannot see you reading it. Okay, So I hope that you read it. Okay. The project was completed. By the way, it was running from 2004 to 2006. So it ended 15 years ago. And now let's go back to my slide. So I'm gonna now try to new share, and now I'm gonna go back. I hope this is gonna work. Okay. By the way, since this was 15 years ago when the project ended, the original website of the project died. Okay, let's rest in peace, poor soul of this site. But you read such optimistic statement about everything which was supposed to be already here. And you know what? If you look around, it's not. So in 2003, there was a claim that we are this close, okay, this close to having it all working beautifully thanks to software agents. We are 15 years later, and it ain't here. So this is what I wanted to really wrap your minds around, thinking, what is your answer to the question, what went wrong? Why in 15 years or more, because it started 2004. So what in 4, 5, 6, 3 years? So what in 18 years went wrong? So we don't have it all. And I want you to go on a journey, rather sad one, that will allow you to find your own answers, but I will make some suggestions. So what are the main features of agents? And by the way, this all of you know, so I'm going to go through this very fast. In many, and this is based on various definitions where I put things together, sort of most generic. What are agents? Encapsulated software objects, which means that they sort of have borders. You can establish where is an agent, where is not. You don't have this 20 million lines of code that describe something that has objects in it and has agents in it. No. Agents are very specific entities, and we're going to come to this. Message exchanges are, at least theoretically, the only way for communication. In agent systems, we should not share things. So there should not be a shared data entity that is shared by multiple agents. If agents want to share something, they have to exchange messages. Everything is based on communication. And again, coordination, you have to communicate. Collaboration, communicate. To collaborate, you need agreement formation, which is based on negotiations, which is based on communication. You have negotiations, and if things go wrong, and this is where the dynamicity is taken care of, you renegotiate. You know it, of course. Mobility. Everybody in the early days of agent systems was so excited about software, mobile software agents. I will make a comment on this, but mobility was very important as a concept, so that agent will move where the data is. For instance, was the story that you will send an agent will do something there and come back. Okay. Now, I didn't put the whole reference because the slide is already overloaded, but you can look for classic seminal work for communication of the ACM of Nicholas Jennings, one of the fathers of agent movement. And there he makes a very nice argument that software agents follow software engineering principles. So the three principles of software engineering that he is mentioning are decomposition, abstraction, and organization. And he says agent-based decomposition partitions problem space, obvious, but nice to put it in this context. Agent abstractions allow modeling complex systems, and he shows some examples how to do it. And agent philosophy allows modeling and managing relationships. So you can use software agents and study and represent dependencies and relationships, and you can form groups, and you can have managers, and you have groups of managers. You can represent the complex domain by hierarchical interactions. Okay, very nice argument. So now, of course, there are other features that people talk about in case of agents, proactiveness, reactiveness, Lochness. We are not going there. We are just focusing on few key features. Now what happens? Since we are talking, and Professor Jennings was talking about software engineering, let's talk about methodology. Well, here you have 4 methodologies that have been designed with software agents in mind. There is Gaia, and one of other speakers is distinguished Professor Michael Wooldridge, who together with Professor Jennings and others were authors or fathers of Gaia methodology. Here you have, by the way, you have the slides because I send it to the conference organizer, so you can ask them anytime. So you will have access to those references. And there are more references to Gaia. Very interesting methodology. There was Prometheus. That is more from your area because it's Michael Vinnikov in Lynn Padam. I think this was Michael Vinnikov's PhD dissertation, and Lynn Padam was his PhD advisor, and it is Australia, Prometheus. Tropos, this is a European product, Paolo Bresciani, Perini, Giorgini. So you can clearly see that the first 4 names are Italian, the last one is Greek. So they created this intermediate agent object methodology for design of agent systems. And the last one is very interesting because it's AML. It's product of our friend, Professor Ganja and mine, Radovan Czervenka, and this is PhD dissertation of Radovan, and Ivan Trenchanski was his PhD advisor. AML was, okay, so you start from UML, which is the Universal Modeling Language for Software Systems. Then you move to Agent UML, which is AUML. And then you have AML, which is Agent Modeling Language. AML was done when Radovan was also working at Weinstein Technologies, which is one of the primary agent-related software companies in the world, which is located in Switzerland. But they have laboratory in Slovakia, in Bratislava, and Radovan is from Bratislava. I can tell you about this because Radovan is a friend of ours, as I mentioned. And there were some tools developed here. So generally speaking, interestingly, AML had tools. Those tools were add-ons to the Star UML. There is this modeling, software modeling library or framework or application. And they created a set of tools that were add-ons to Star UML that you could use to generate AML diagrams that represented agent systems. And there was a whole methodology behind it. And you know what? In summary, tools that Radovan developed don't exist anymore, at least nobody can find them anymore. If you talk to Radovan, maybe he would send you some stuff, but it is from 2007, 2008. Software engineering is progressing with multiple methodologies, tools supporting them in one form or another. Agent systems have those 4 methodologies, so we can say head methodology because they are the most recent one is from 2007. There is not much work that seems to be done on software agent methodology, and there are no tools. I, by the way, talked to Lynn Padam and asked, and there are no tools at all. AML tools are gone, Tropos tools are gone. I'm not sure about Gaia tools, but I predict that they are also gone, even if there were any. Interesting, isn't it? We are to do software agents, but we don't have tools. Interesting thing is how to add brains to agents, because agents are supposed to be intelligent. Okay, everybody's talking about intelligent software agents. Intelligence is somewhere there. Okay, how can you make them intelligent? Well, the basic approach is to write Java code if your system is Java based, or maybe if your system is BDI, you know, belief, desire, intention, BDI systems. And typically they require rules, BDI rules in XML. Maybe you can use some XML tools to write those, but it is so 20th century. Yes. Now we looked with our student Marius into rule-based expert systems. Look, in 2014, there was not much of big learning, deep learning, and so on, but people did a lot of work on rule-based expert systems. So we asked, can we encapsulate rule-based expert system? And you know what? It was not easy to find anything that would naturally encapsulate. There was project rules, for instance, but it died in 2013. Okay, not good. Semantics. Well, in this paper, which is listed there, by the way, I'm using those papers not to promote me or Maria or Marius. It's just, it happened that we were interested in this, so I'm just sharing it, but it is not big breakthrough in sciences. But we looked into encapsulating some semantics into the brain of software agents. And you know what? You can do it, but the question is, semantics is resource consuming. So encapsulating Jenna, for instance, into the brain of software agent, first it is resource consuming, but then it will not be most likely fully encapsulating, because Jenna needs a triple store, and triple store is going to be outside of the agent. So you are breaking your assumption that it's going to be fully encapsulated software entity because it's going to be using a database. Oh, triple store is a database. Okay, something is not so good. You could encapsulate some models resulting from machine learning. You can train a deep convolutional neural network and then put it as a brain to the software agent. You can do this, but if you don't have enough resources to run the software agent, you may have a problem with running it with a deep convolutional neural network. And model training, you're going to have to do outside. So you're going to have, in a sense, take an artifact and stick it into the brain. But if you update the model, you're going to have to do brain replacement. Brain replacement is not easy. There's another paper, if anybody's interested, we did about modifying brains of Jade agents. So it seems that the only realistic way is to write code for intelligence. But is it really a good way? It is 20th century. What are the platforms? What is the state of the platforms? Well, there's Jade. Jade is good because Jade is developed by Telecom Italia, is used within Telecom Italia. So it is industrial strength. The problem is that Giovanni Caire, who is also a friend of ours, who is the lead for Jade, already a few years ago told us that the last release was 2017 and it's going to stay this way because it's feature complete from the point of view of Telecom Italia and no updates are planned. I will comment about mobility in a moment. Okay, so there is industrial strength tool, open source, nice, except that it is not updated now for 4 years. There is Spade. Spade is nice because it is with last release from July. It is Javier Palanca project. It is Python based. It starts to get contributors. So this is nice. It starts to get add-ons. The newest add-ons are from July. So there's something happening there. Of course, if you have Python, you can easily envision that this deep convolutional neural networks or whatever, regardless of potential issues with resources, or maybe using a TensorFlow on the outside and use it for for your brain, which breaks the encapsulation, it's easy to do because it's Python. Okay, Python with Python works well. But once upon a time, Mr. Palanca did not have time to do updates, and this system was for more than 2 years dead. Well, dead. I mean, it was there, but no updates. So the question is it reasonable to assume that it will keep on going? By the way, it has also some issues with messaging because it's using an unusual protocol. And when our students wanted to do ACL messaging, they had to rewrite large parts of code. There is JSON, which is a BDI platform, and JADEX, which is also a BDI platform. And here I have doubts about JSON, because even though last release on GitHub was from April 2020, last news on the main page are from 2019. So it's almost 3 years. There are, well, 2 years, 2 full years almost, no news. This doesn't look good. JADEX, after more than 3 years of break, or even maybe 4 years, finally has a new release. It's from July this year, and it has two things that are unusual. It has BPMN workflows, which is very interesting from the point of view of methodology, because here the methodology of BPMN can be used, and it has Android. So since I just found out preparing this lecture for you guys, we definitely need to look and talk, because also JADEX creators, Professor Braubach, for instance, is a friend of ours. Yes, so Hamburg team, we know them, we need to talk to them. So maybe this is a potential future. The only thing is, it is active components. They don't see it as agents. So there is a bit of technical issue here. And then there is agent-oriented software company in Australia, which is a commercial company which is monetizing agent technology, and they are openly saying that they are doing it. As a matter of fact, on their main page, you have a nice video from YouTube of lecture by Professor Wooldridge. So if you want more Wooldridge than today's conference, well, today's presentation, you can go to AO's page and get yourself more Wooldridge. The younger Wooldridge version would be. Very nice video, by the way. It's Introduction to Multi-Agent Systems. The only thing is that they are on their main page making claims about something that we were to deliver early in 2020, and it's not delivered yet. Maybe it's COVID related. Maybe there are some issues there, but this starts to be tricky, and I don't know what's going on. Okay. Now, there are special platforms that are for simulation. One of them is NetLogo, which is like Logo, the turtle. It is agent platform, Uri Wilensky's product, very nice, with new releases coming regularly. It's mostly for education. If you go to the website of NetLogo, you will understand very easily how it is. It would be very good for something like high school kids, or maybe higher grade elementary schools. They can do this, and they can play with NetLogo. Very nice. But it is for education. Now, there's Repast. Repast has released less than a year ago. Other than the one in parentheses, it's the high performance computing Repast, which has not been updated for a while. We had some students in 2015, so few releases earlier, who were playing with this to do some simulations, some crazy stuff. Students were crazy. We love those students. They were like absolutely wild bunch. They used Repast, and they were having problems with documentation. They didn't like the way that Repast allows visualization. They wanted some more cool graphics. They were able to hack in some cool graphics inside. But later on, one of them, I think that it was precisely Michał Słupczyński, who did something that could be done with Repast, but instead he used Unreal Engine to develop his software. Because it was game related, he could use Repast, but decided to go with something more visual. Okay, but this leads us to an interesting area, visualization. Quite often you want to combine agents with maps because you want to, like the track that goes from Penang to Kuala Lumpur, you know, my favorite example. So how you can combine software agents with maps? And here you immediately run into interesting issues because Google Maps gives you an API. You can work with it, but they will, they give you a limited number of requests and then they say, okay, pay us, give us money if you want to use Google Maps. We will not give you Google Maps for free if you are constantly trying to issue requests for mapping. So not good for education. OpenStreetMaps is open, but it can be too slow. Students run into an issue, and when they were interested in running larger simulations, they were caching maps locally. Okay, why am I talking about this, and why this darn track that is traveling from Penang to Shah Alam? Well, because in the proceedings of this conference, you will find little paper, I mean, just little thing about simulating car platooning. What is platooning? Platooning is if you have multiple cars that will form like a road train. They will have, first car will be driven, let's say by a human, maybe supported by autonomous driving thing, but the subsequent cars will be driving autonomously. They will be talking to each other. So you have gossiping cars and they will be traveling quite close to each other. I'm not sure if you have seen NASCAR racing. This is the American races with these like normal cars running in circles. Yeah, they are running very close to each other. We are talking NASCAR racing. They are like around a meter from each other, maybe meter and a half. Well, on the roads, you can have like 5-6 meters between the cars. And because of the drag force of the how the air is around the train, the platoon, you get much lower fuel consumption in subsequent trucks. Okay, they don't have the air resistance to conquer. So they were traveling. My students were looking, or our students, because it was Maria, was also involved looking into Sumo, CityFlow, and Gamma. And they found that those simulation platforms are not interested into the deep agent logic. They have this agent thing where you have individual cars that you can model, but gossiping cars are not easy or possible, depending on the case, to really implement. Or it could be hell. I mean, my students can do anything. They are great hackers, but they decided to develop their own little simulation thing to just play with the ideas and explore them. So in the proceedings, you're going to find this. Now, there are two phases of mobility. What I name two phases. You can have standard agent mobility, and you can talk about strong mobility, which strong mobility is you can complete a bytecode, single bytecode, and move, and the whole stack moves with it. Our friend Naranjan Suri from Pensacola did this in the Nomads platform. Nomads platform, by the way, is dead. And this is the only attempt, or the only large-scale attempt to deliver strong mobility. Jade was not so weak mobility. But you know what? Honestly, I don't believe in agent mobility, in the need of agent mobility. However, I believe that agents are on mobile phones, can be on tablets, on phablets, on laptops. And then the question arises, what can you use to put them there? Okay, JDEX, this new thing that we have to explore, runs on Android. So there is something there that is worthy trying. But Jade on Android doesn't work. Android tries to kill agents. Mariusz reports in this paper with us that we were able to find a way to prevent Android from killing Jade agents, but it is unclear with the new releases of Android if they will not find a way to go around our way of stopping Android to kill Jade, and how it was not fun. So I am really looking forward to what JADEX has. Communication. Communication is the whole workhorse. I mean, everything in agents is based on communication. There is a FIPA standard, ACL language, but you know what? Things like SPADE or JSON, they don't much care about FIPA standard ACL. Jade has ACL, full blown. Others are sort of agnostic about it. And FIPA is dead. They didn't do anything. I mean, there is the website, there is a bunch of people listed as bosses of FIPA, and nothing is happening. Communication between platforms, even more important. We have multiple platforms. Okay, so we did Jade with maps. We did Jade with Exat. Exat is an Erlang-based platform by Corrado Santoro. Fine. We generalized this a little bit. But there is an open situation with communication and mobility and mobile devices. You see, communication in agents was conceptually approached when you had bunches of PCs connected via cables or via wireless, but they were connected to the internet. They didn't have much mobility, where mobility means that in one moment you have internet, in another you switch it off to preserve battery, and then you switch it on and you have again internet. Communication in such dynamic situation where communicating nodes can come and go is not well supported, at least unless JADEX did something miraculous. And I am really, again, curious about JADEX. By the way, I mentioned all those assistants that can be treated as software agents. The Patty May's definition of software agents would be those assistants. They don't talk to each other. We had a student project. They were not the best students, okay? I have to admit it. But they were trying to have Cortana talk to Google Assistant. They didn't succeed. There were so many mechanisms to protect agents from one company from receiving anything from the outside that they couldn't break through. Maybe it's possible. I am not saying that it's not possible, but there is difficulty to make Siri talk to Cortana. Okay, doesn't work. So, by the way, there are two related approaches that I want to mention because I want to comment on them on the next one. There are grains, which are part of the Microsoft Orleans. There's going to be a link, but you can find it yourself. Grains are conceptually smaller than agents. And we have this semester that ended in June, we had a group of students who were like totally MS.NET, C#.NET crazies. And, you know, they explored Orleans for the first time. We had some students who wanted to do this, and they liked it. They liked it. They delivered something, some functionality with the semester project. There is also actor model, and I will not read this because I'm already speaking too long, but you have then tools like Akka, which is extremely popular, and Erlang, which is a very popular language for actor systems. It's originally from Ericsson, and it's a functional language, but it's very popular for distributed systems. So now, with all that I have said so far, let's take a deep breath. This is what we have. This is what I see. And I'm not sure if you're going to see it my way. Maybe you can be more optimistic. But methodology. In theory, we have some methodologies for development of agent systems, but they have no tools. And we don't see too much work done on further studying them, developing tools, and using them. Agent and device mobility is problematic. I hope that Hamburg friends solved some of the problems. Platforms, we need a lot of new developments. We need a lot of community effort. And unfortunately, Jade is not much a community effort. They could put it on GitHub maybe and let people play with it. Standards. Everybody in every branch of computing, computer science, computer engineering talks about standards. Since FIPA is brain dead at this moment, or a zombie, what should we do? How can we get standards for agent-based computing? Because without standards, how are you going to design industrial strength tools and industrial strength systems, which are not standardized at all? There's a bit of a problem here. How to efficiently, effectively implement and modify agent brains? Because writing Java code or writing XML-based rules for BDI systems is year 2021. We have to find better way of doing it. Agent communication, especially with mobility, communication and mobility, agents on truly mobile devices, agents on cell phones, how they communicate within a platform, within an ecosystem. We need some more work done here. And look, this is why I put the previous slide. Orleans is a Microsoft product. Microsoft is claiming that it's very good to use with Azure Cloud. Maybe people are using it. But even more, Akka and Erlang. There is a lot of work done around Akka. Big systems are designed using Akka. There is a website where you can find out how many large industrial scale systems use Akka. So look, Akka is used, but Akka is just actors. We have agents which are supposed to be this big thing. We were told in 2004, 2006, agents are great. And where are they? We don't see them. Well, okay, so there's a good news. It seems that agent systems are coming out of the Gartner abyss. You know, Gartner curve, you have this big expectations, and then you go to abyss, and then you come out. I hope that you know, you find yourself the Gartner cycle if you don't know what I'm talking about. Siemens, within the company, is developing an agent platform for IoT. And we know it because Arne Breuering, whom we met in our first IoT project, and now we are with him in, not with him, but he is in another parallel IoT project, mentioned this. So they are in the process of developing agents for IoT. Whitestein, which is the big company, is talking about agents. And if you go to their website, look around, you will see advantages of multi-agent systems for logistics. So people start talking. They are not hiding agents anymore. They are talking about agents as an interesting approach. So whatever during the Agent Link 3 was claimed to be the great time, people are starting again to believe, like in the Matrix 1, he begins to believe, people begin to believe in software agents. So what do we need? And you know what? Here's what we need. I have very mixed relationship with this piece of writing by Hyacinth Mana and Divine Ndumu, which is from 1999, so it's 22 years old. And I will read a little piece of it for you, because it is a reflection like mine, but a reflection from 1999. In 1999, Van and Ndumu said, our evaluation has highlighted the fact that not much discernible progress has been made post-1994. Perhaps because, and here's the first key part, researchers have failed to address the practical issues surrounding the development, deployment, and utilization of industrial strength production systems that use the agent technology. We know that the that once greater effort is placed on building, and here again stressing, useful systems, not just prototype exemplars, the real problems will begin to be addressed. And this is what they say. Agent researchers need to descend into the swamps of real life dirty problems to confront the real problems that plague the realization of the potential of agent technology. And you know what? I reread it. I read it many years ago. Then I was using these ideas of Nirvana and Doom, then I stopped. And now I reread this latter part. And you know what? This is why I put this whole presentation. We really need to confront the real problems that plague the realization of the potential of agent technology. This is what we have to do. So how to find me? Because this is the last of the slides. You have here email, you have here LinkedIn, you have my website, my Google Scholar, my website to the projects, agent projects and agent publications. And if you would like to join us, Professor Maria and myself, to jointly explore the swamp, roll our sleeves and get dirty, talk to me. Send me an email. Thank you for your attention. I hope that this was something that makes you think. You may completely disagree with me. You may think that Papszycki is crazy. Please do. But reflect on what I pointed to you and let's try to fix the issues. Or maybe your work is such that you already fixed them, which would be great, which would be fantastic. I hope that next time, whenever the next time is going to be, we're going to have a chance to meet in person and talk. And for the time being, guys, please stay safe, vaccinate if you didn't yet, avoid getting COVID because it's a really nasty beast. And thank you very much for your attention. And at this moment, I'm going to stop sharing. And now, thank you all. I hope that you're going to have some fun and I stop recording now. Stay safe.
Thank you very much, Professor Dr. Marcin. So we will be going for a morning break shortly and we will continue the session at 11 a.m. Thank you very much. See you guys later, ladies and gentlemen.
I love taking pictures.
A few months ago, I joined Fit Club. It's under IT department. When I was doing my SPM, I did well in IT, and I wanted to become a hacker. So when I saw Uni10 has cybersecurity, I was like, oh, okay, I think it's meant to be lah. Almost every day, I wake up, mandi, then semayang, go to the class, eat, hang out with my friends, go to some other classes, and then go back home, watch movies. This is the place where my dream's gonna become reality.
My name is Faisal. I'm from Morocco. I really wanted to be a psychiatrist. but my love to physics drove me to engineering. Uniten is producing one of the best graduates all over the place. I started searching about Malaysia, started reading more, I started reading about Uniten, and I felt that it was really interesting. So being here is a challenge. I love to make myself as busy as I can, so I'll do a lot of futsal, football, and gym and swimming is #1 in terms of time consumption after university. I'm trying to keep myself as healthy as I can. I'll be making my breakfast if I'm waking up early. If I'm not, then I will just head directly to classes. And after finishing up my classes, I'll be having already my gym bag packed. So from there, directly to the gym, doing some workout. Most probably I'll be leaving the gym around 9 or 10. I'll be having a few hours left for me to catch up with some studies and definitely do that. So far, being in Uniten is a great chapter of my life.
I'm playing hockey since I'm 8 years old. 15 years old, I already playing for country. To manage my schedule every day, I communicate with my lecturer, and the most important thing is discipline. Be punctual on time. In a day, I have a very short time. I woke up about 6:15 a.m. and then I have classes from 10 a.m. to 4 p.m. Usually at 1 and have lunch and maybe a short nap at Masjid Uniten. Then I will rush back for hockey training session in the evening until 7 p.m. Then at night, I have to settle my assignment or just do some revision before I get a good sleep. Hockey is my life. In 2020, I have 2 missions. First one is I will finish my degree in energy economics, and the second one, I will bring our hockey team to the Olympics.
I did my research. Uniten is the best engineering university in Malaysia. I put myself here. You can see all the facilities, the lecturers, how they handle things professionally. They give exposure to students like me. When I'm taking mechanical engineering, they don't just talk about it. They show us the machines, like lathing, drilling. I get to touch and operate some of the machines. I'm not really active in co-curriculum, but you need to participate in Uniten activities. There's this one activity, it's called Faith in Humanity. When I go to KL and meet all the homeless people, I was there. You know that feeling when you connect with someone who has nothing. They live in the alleys, in the streets, and they're kids. You know, we connect with them, we talk about them, and it's really beautiful. I thank God every day because what I have today, something that I will treasure, and I thank Uniten for that.
Uniten offered me to do my full-time research in mechanical engineering. So at the same time, to integrate a bit of computer stuff, programming, into my mechanical knowledge. That's why I choose Uniten, because I can integrate both of them into my research. 7. My breakfast, everything done. By 8, I'm in office, try to schedule my day. And sometimes I have classes to teach as well. So I finish my classes, then I have to do my research. And mostly I have to go out because I was working in the hospital, right? So I have to go and meet ophthalmologists there. And then I'll be back in Unit 10, say around 4:30. I go for my swimming at 5:30, dinner, and then probably a bit of entertainment. It has everything, so it's quite a versatile campus.
I like to go jog to release some stress. I used to swim and I did my taekwondo halfway. I used to play javelin and sometimes I go for yoga. I wanted to be an accountant. I have a lot. I wanted to be firefighter. It was actually my parents' choice for me to take engineering. I actually kind of like this course because it's challenging. It has a lot of hands-on and it's very interesting that you get to learn how to assemble parts by parts. So apart from studies, I like to go cafe hunting with my friends and try some new food. When I wake up, I have to do my hair first. I will take about 15 minutes to do my makeup. Then I will go to class. I usually have 2 to 3 hours break. I will go out and eat. I have club meetings at night. After that, I'll go lepak with my friends and I go home. Unit 10 is actually my second home as I spend 5 days in a week in Unit 10 and that's where I sleep and I would say it's a home for me.
taking pictures.
A few months ago, I joined Click Club. It's under IT department. When I was doing my SPM, I did well in IT and I wanted to become a hacker. So when I saw Uni 10 has cybersecurity, I was like, oh, okay, I think it's meant to be lah. Almost every day, I wake up, mandi, then semayang, go to the class, eat, hang out with my friends, go to some other classes, and then go back home, watch movies. This is the place where my dream is going to become reality.
My name is Faisal. I'm from Morocco. I really wanted to be a psychiatrist, but my love to physics drove me to engineering. Uniton is producing one of the best graduates all over the place. I started searching about Malaysia, started reading more, I started reading about Uniton, and I felt that it was really interesting. So being here is a challenge. I love to make myself as busy as I can, so I'll do a lot of futsal, football, and gym and swimming is number one in terms of time consumption after university. I'm trying to keep myself as healthy as I can. I'll be making my breakfast if I'm waking up early. If I'm not, then I will just head directly to classes. And after finishing up my classes, I'll be having already my gym bag packed. So from there, directly to the gym, doing some workout. Most probably I'll get into the gym around 9 or 10. I'll be having a few hours left for me to catch up with some studies and then maybe dinner. So far, being in Uniton is a great chapter of my life.
I'm playing hockey since I'm 8 years old. 15 years old, I already playing for country. To manage my schedule every day, I communicate with my lecturer, and the most important thing is discipline. Be punctual on time. In a day, I have a very short time. I woke up about 6:15 a.m. and then I have classes from 10 a.m. to 4 p.m. Usually at 1 and have lunch and maybe a short nap at Masjid Uniton. Then I will rush back for hockey training session in the evening until 7 p.m. Then at night, I have to settle my assignment or just do some revision before I get a good sleep. Hockey is my life. In 2020, I have two missions. First one is I will finish my degree in energy economics, and the second one, I will bring our hockey team to the Olympics.
Good morning and welcome back, ladies and gentlemen. We will continue with the session today. So before we move on into the opening ceremony, we would like to invite Dr. Muhammad Amin bin Muhammad Yunus to recite the dua.
Assalamualaikum warahmatullahi wabarakatuh, and peace be upon all of you. Al-Fatiha. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Arrahmanir rahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. Indeed, we gather today to express our gratitude for your priceless grace. Make us slaves who are always grateful whether the favors are little, even the favors that abound to us. Ya Allah, Ya Rahman, Ya Rahim, please give your blessing to our fourth International Symposium on Agents, Multi-Agent System and Robotics 2021 today. Indeed, you are knowing that we are here want to gain your vast knowledge to improve our knowledge as your servant, whom you are pleased with. So bless and bestow our gathering. Give us your knowledge, lighten our hearts with your light and guidance. Hopefully, with your mercy, we can easily accept and appreciate as well as practice it. Ya Zal Jalali wal Ikram. Ya Zal Jalali wal Ikram. Grant us the health of the limbs, mental fitness, peace of mind, strength of spirit. Hopefully, with your favor, we will be able to face challenges, be competitive, and be able to elevate the dignity of ourselves, family, community, and country. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وقنا عذاب النار وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم سبحانك ربك رب العزة عما يصفون والسلام على المرسلين والحمد لله رب العالمين. Assalamu alaikum warahmatullahi wabarakatuh, and peace be upon all of you.
Thank you very much, Doctor. So we shall start with the opening ceremony. Ladies and gentlemen, the management of UTHM, the organizing committee of Isamsr 2021, respected speakers, distinguished guests, ladies and gentlemen, a very good morning and welcome to the 4th International Symposium on Agents, Multi-Agent System and Robotics 2021, Isamsr 2021. The International Symposium on Agents, Multi-Agent System and Robotics 2021 is a premier platform for students and researchers to share their new ideas, original research results, and practical development experiences in the theory and practice of autonomous agents, multi-agent systems, and robotics. The Isamsr 2021 is being held on a virtual conference platform and is hosted by University Tun Hussein owned Malaysia, UTHM. This symposium is sponsored and supported by IEEE System, Man and Cybernetics Society Malaysia chapter. The objective of Isamsr 2021 is to provide a regional platform for researchers and those who are interested in research in the areas of autonomous agents, multi-agent systems, and robotics to meet, present their research results, problems, and issues in an open and informal academic environment. It is also to expose novices to major topics of autonomous agents, multi-agent systems, and robotics. Last but not least, it is also to survey an area of agent research especially relevant for people from the industry. Ladies and gentlemen, without further ado, we would like to invite Associate Professor T.S. Dr. Aida Mustafa, the Chairman of Isamsr 2021, to give the welcoming speech.
Assalamualaikum and a very good afternoon, a very good morning to everyone. Welcome to 4th International Symposium on Agents, Multi-Agent Systems and Robotics, Isamsr 2021. My name is Aida Mustafa and I'm serving you as the chair for the symposium. I am an associate professor from the Department of Mathematics and Statistics, Faculty of Applied Science and Technology, University Tun Hussein On Malaysia. Isamsr 2021 is hosted by the Center of Intelligent and Autonomous System, Faculty of Computer Science and Information Technology, University Tun Hussein On Malaysia. And on behalf of the committee, I would like to thank our co-host, our industrial partner, TNB or Tenaga Nasional Berhad Integrated Learning Solution, ILSAS, our academic partners, our long-time friends, University Tenaga Malaysia Uniten, University Technology MARA UITM, as well as University Kuala Lumpur UniKL. And as tradition, Isamsr is also technically co-organised by IEEE Systems, Man and Cybernetics Society. It is our honor today to present you 5 distinguished keynote speakers whom are outstanding researchers in the area of agents, multi-agent systems, drones and robotics. We have the first one, Professor Dr. Michael Wooldridge, University of Oxford, Associate Professor Dr. Marcin Papiski from the System Research Institute, Polish Academy of Science. I believe we all have the opportunity to listen to their keynote speech this morning. And we will be having 3 more keynote speakers. Tomorrow, Associate Professor Dr. Rainy Alfred from University Malaysia Sabah, Associate Professor Dr. Muhammad Tahir from Karabuk University, as well as Dr. Muhammad Zaliman Muhammad Yusof, Head of Strategic Digital and Innovation, TNB Integrated Learning Solution, ILSAS. A bit on history, Isamsr was born from the Center of Agent Technologies in Uniten. We started a small research group in 2008 and I keep on repeating the same story every time we have the symposium. It is our fourth times now this year. And we started very small, only with 4 people. Our mentor, Prof. Sharifuddin Ahmad, has now gone into retirement. I myself was coming from UPM, University Putra Malaysia, back in 2008. We have Dr. Zaliman, who will be delivering keynote speech tomorrow morning. We have in our small team Dr. Azhana Ahmad. She will be delivering presentation for session 3 tomorrow. And we have Dr. Muamin also as a track chair for our autonomous system. The small group later expanded into a full-fledged research center, which were driven by most of the group of friends, our dear friends who are working very hard to bring this event to you. If I can name a few, Dr. Salama, UTHM now, Dr. Shaz from UniKL, Dr. Zalhan, UniKL, Dr. Shamini, Uniten. We had the first symposium back in 2015. So the first Isamsr was hosted by Uniten. And then we had the second Isamsr in 2016 was hosted by UniKL. And the third Isamsr was hosted by us, UTHM. It was a physical conference at Putrajaya. I remembered visiting Prof. Wooldridge in Oxford back in early 2018. We wanted to ask him to be our keynote speakers in third Isamsr, but he couldn't make it due to his tight arrangement. So here we are now. We are in the fourth Isamsr. We are back at UTHM, but it is on virtual platform this year. And I would like to remind everyone that the objective of this symposium is actually to share research and ideas on forefront technologies as well as work in progress among all our students. We have postgraduate students, we have postdoctoral students as well in our group in the area of agents, multi-agents, Internet of Things, IoT, drones and robotics. We sincerely hope we can reach out and extend our research circle with academicians, industrial partners, and we are able to share potential research grants, student supervisions, and perhaps research or teaching attachment across institution. Again, thank you for joining us for this event. Stay connected, and we are looking forward to see you in our next event. Thank you so much.
Sorry. Thank you very much, Dr. Aida. It's always a pleasure to listen to your speech. Ladies and gentlemen, we will move on to the next person. We would like to invite Dr. Salama, the main organizer of Isamsr 2021. He will be introducing the Center of Intelligence and Autonomous System from the Faculty of Computer Science and Information Technology, UTHM.
Okay, Assalamu alaikum wa rahmatullahi wa barakatuh, and good morning. For all participants, and welcome to the 4th International Symposium on Multi-Agent Systems and Robotics, Isamsr 2021. I am Salama Mustafa. I am a senior lecturer at the Faculty of Computer Science and Information Technology, UTHM. I would like first to thank UTHM top management, our Vice Chancellor, Prof. Our Vice Chancellor, Prof. Dr. Wahid Razali, our TNCPI, Prof. Dr. Muhammad Shahir Shamsir, our beloved Dean, Dr. Azizul Azhar Ramli, and our Deputy Dean, Associate Prof. Dr. Khairul Nizam Mahdeen for supporting Isamsr 2021. I would like also to thank the keynote speakers for their tremendous speech on agent and multi-agent system, and Isamsr committee for their hard working to make Isamsr successful. I also would like to thank all the participants for their contribution to Isamsr 2021. Without you, we will not be able to achieve our objectives. Okay, I would like in this presentation to introduce the Center of Intelligent and Autonomous Systems, CIAS, which is the first trigger to Isamsr 2021. Okay, the first version of, as Dr. Aida mentioned, the first version, it was in Unit 10 in 2015. And it was under the Center of Intelligent and Autonomous Systems. Okay, so I will just give you a brief introduction about CIAS. Actually, we don't have a very broad history because we are a new center. It is just established in April 2021, but we have a big ambition to contribute to the faculty, to UTHM, and to our community. Our center is focusing mainly on three main areas, which are autonomous systems, including autonomous agent and multi-agent systems and their applications. The second area is intelligent systems, including machine learning, deep learning, and reinforcement learning and their applications. The third area is Internet of Things, including edge computing, intelligent things, and their applications. CIAS objectives of establishments are to propose advanced intelligent and autonomous systems, frameworks, models, and architectures that are functional, practical, and implementable for a new and existing solutions. To foster interdisciplinary smart systems that encourage innovative, groundbreaking, and sustainable solution to improve the quality of life. And finally, to promote the use of intelligent and autonomous systems for increased efficiency and safety, especially in industrial process. I would like to introduce the CIS researchers. Actually, we are currently a small team, six principal researchers, one affiliated researchers, and incoming we have a postdoc, we have several PhD student, master students under CIS. Okay. I would like first to start with our Dean, Dr. Azizul Azhar. His research area are fuzzy logic, fuzzy system, knowledge-based systems, dynamic data analysis, web mining, web usage mining, fuzzy regression analysis. So basically, different type of approximate reasoning algorithms in real-world applications. Our second principal researcher is Hairul Nizam Mahdi. He is our Deputy Dean Research, and his research area is data management, complex event processing, information retrieval, and currently he is focusing more on data analysis related to IoT smart systems. We have Dr. Shahri Qasim, very hardworking and always secure industrial grant. His research area is in clustering classification algorithms, basically in machine learning for data analysis. Our following principal researcher is Dr. Muhammad Saeed Jawad. He joined UTHM last year, and his research areas and interests are telecommunication, IoT sensors, 3D modeling, cloud-based AI platforms, and virtual augmented reality. Then we have Dr. Naif Abdul Wahab. He is UTHM alumni, and he joined UTHM as lecturer in 2019. His research areas is in Internet of Things, the practical aspect of Internet of Things, edge computing, efficiency of Internet of Things is like safe power and or energy. And our program chair, our conference chair, Dr. Aida Mustafa, her research area in intelligent and autonomous systems, agent-based systems, computational linguistics, and soft computing. Last but not the least, it is me. I am the head of CIS. My research areas actually I am very proud. So it is mainly artificial intelligence, machine learning, autonomous multi-agent systems, and combination of these three. I would like to show some of the projects that are ongoing now in our center. One of the projects is Coordinated Data Fusion Agents, CDFA system, which is a collaboration project with the Sena Traffic System to make data fusion for their traffic monitoring and control center. So basically this project will process different type of heterogeneous data sources, camera, sensor, raw data, and try to extract useful features that can be used to optimize the traffic light controller process. This is another sample of our projects. It is a smart water metering application. It seems a simple project, but actually our main objective here is to reduce the energy usage. So the research aspect is to reduce the energy usage of IoT system, okay, by controlling the water level. And it is done by Dr. Naif. Another sample is intelligent essay automated scoring and evaluation system. This project is handled by Dr. Said Jawad, and it is also a funded project. And his proposal is to increase existing grading efficiency for the essay. So automated marking. We have two more projects from Dr. Associate Prof. Dr. Shahrin Qasim, and these are projects with the industry, both of them. The first one is critical maintenance management systems, working with MZR Global as the Berhad. Okay, so basically this is information system project with some optimization theories. The other one is software design specification for data DPP, which is D1 Bahasas Pustaka. Okay, and this project is about software engineering and software requirement specifications extraction for their existing system. It is like reverse engineering project. Okay, our incoming project, this is very interesting. We try to use a drone in our labs to make the student more attractive to programming. So the basic idea, we use these teledrones in our lab to teach students how to program in Java. Okay, in the lab we have different type of exercises that the students will do, and the drone will simulate, let's say, control statements, loop statements, and so on and so forth. And the other one, we are planning to use Romba and robotics projects. So the aim is to attract students to do autonomous robot research. You can visit our website at cias.fsktm.uthm.edu.my to view some samples of the projects. And I take this opportunity to welcome and encourage and seek research collaboration opportunities with other research groups. Please feel free to contact us for collaboration of research. I would like to welcome you again in Isamsr, and I wish you all great success. Thank you very much.
Thank you very much, Dr. Salama. We would like to continue the session. So we would like to very much welcome TS Dr. Azizul Azhar Ramli, the Dean of Faculty of Computer Science and Information Technology, UTHM, to give the opening speech.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and salam sejahtera. May the blessing from the Almighty of God befall on us, and I would like to express my good wishing of Malaysia Prihatin in welcoming you and all the participants on this special conference. Thank you very much, Chairperson. The Honorable Associate Professor Dr. Aida Mustafa, Isamsr Chair, the Honorable Keynote Speaker Prof. Dr. Michael Rich from University of Oxford, The honorable keynote speaker is Professor Dr. Mersin Pavlitsky from System Research Institute, Polish Academy of Science. Distinguished guests, ladies and gentlemen. It's give me a great pleasure to welcome you to today's conference, the International Symposium of Multi-Agent System and Robotics 2021, or Isamsr 2021. Agent and multi-agent system and robotics has always becoming exciting research topic in computer science. The importance of those fields is becoming more critical, especially in IR 4.0 era. In this conception, the product controls their own production, since this product and component communicate with the machine and equipment by unique product codes during their production. Smart factories will be self-regulating and optimize their own operation. Consequently, it means that virtual and actual reality merge together during the production. By multi-agent, they can detect the signal of the environment and react to them. So, people, machine, and computers, and etc. can be agent and can cooperate and interact each other. In the industry, this agent present machine controllers, robotic, which use a common language to provide cohabitation and collective work. Strong knowledge in these areas would certainly help in addressing many new potential problems in computer science toward a better solution in managing our daily operational needs. Ladies and gentlemen, the main objective of this conference is to realize our university mission and vision through research activities and collaboration. Therefore, I'm thinking this opportunity to express my gratitude to all participants, especially researchers, academicians, and students for attending this opening ceremony for Isamsr 2021, where the aim of this conference is to bring together research and practitioners from academia and industries to focus on advanced robotic and agent breakthrough, as well as establishing new collaborative in this area. My special appreciation also goes to our keynote speakers for taking time to be here with us to share their knowledge and expertise on these important subjects. I am very pleased to have such great speakers present at our conference today. I'm looking forward to a productive discussion among all of the participants, including both speakers and audience. A special congratulations to the organizer, the Center of Intelligent and Autonomous System, CIAS, from Faculty of Computer Science and Information Technology, University Tun On, Malaysia, and the co-organizer, including ILSAS, UNITEN, UNIKL, UITM, for successfully organizing this conference. With this, in the name of God, most magnificent and most benevolent, I open the 4th International Symposium on Agent, Multi-Agent System and Robotic, or Isamsr 2021. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi ta'ala wabarakatuh.
Thank you very much, ladies and gentlemen. Welcome back. Thank you again, Dr. Azizul Azhar Ramli, for the welcoming speech. So, ladies and gentlemen, we shall continue the session. There will be presentation sessions after this. So, please join the presentation sessions. According to the itinerary, we will have to start the sessions at about 11:30. So, please enjoy your session. Thank you very much.
Alright, Assalamualaikum warahmatullahi wabarakatuh and good morning to all. Thank you, Dr. Shamini. Alhamdulillah, we are now have come to our first presentation session. So ladies and gentlemen, distinguished guests, I would like to welcome to all of you to the 4th International Symposium on Agents, Multi-Agent Systems and Robotics 2021. So for this first presentation session, which is the title is the Intelligent System Track, in this session, we will have 9 presentations from our esteemed speakers. The chair of this track is Dr. Muhammad Said Jawad from University Tun Hussein on Malaysia. For today's presentation, the question and answer session will only be available for live presentation only. So if it's a recorded session, so there will be no question and answer session for that presentation. So without further ado, I would like to welcome our first presentation from the University Kuala Lumpur, Malaysia, Malaysia France Institute, Malaysia. The presentation from Mr. Harold Japo Anak Undit, Mr. Muhammad Fazil Abu Hassan, and Dr. Zahan Muhammad Zain, with the title Vision-Based Unmarked Road Detection with Semantic Segmentation Using Mark RCNN for Lane Departure Warning System. Please welcome.
I'm Harold Japo Anak Undit, your presenter for today, and I'm supervised by TS Dr. Muhammad Fazil Abu Hassan and Dr. Zahan Muhammad Zain. Today, I will present to you my paper about vision-based unmarked road detection with semantic segmentation using mask RCNN for lane departure warning system. Before that, let me together take a look of this montage.
Lane departure warning systems track a vehicle's position within a lane, usually with a camera mounted on or near the rearview mirror.
The camera is designed to recognize lane markings.
If the system determines a vehicle has or will inadvertently stray out of the lane, it alerts the driver.
LDW may not detect all lane markings or lane departures. Accuracy will vary based on weather, speed, and road condition.
Vision-based LDWS have been developed over the past 20 years due to the problem road fatality accident that caused by lane exit, as stated in the video, right? Then, this Vision LDWS is an essential function for the intelligent vehicle nowadays because it can give warning to driver if their car drift near, onto, or over the lane marking. The current cars such as Toyota, Honda, Hyundai, they have a camera mounted on the top of the windshield to detect the road line in order for the vision-based LDWS to fully function. The current problem faced by the LDWS here is it having a detection difficulty while it operating in complex environment. This complex environment cause the LDWS to generate a false warning into a driver. M. Peng stated that complex environment can be categorized as a fading and missing road marking and also known as unmarked road. Say data recorded that there is 3 categories of unmarked road existing in Indonesia, which is paved road, gravel road, and earth road. The total length of the paved road is 17,814 km. Gravel road total length is 41,138.8 km, while the earth road have a total length 17,457.2 km. So these data are retrieved from the say data. So the main objective here is to develop vision-based unmarked road detection with semantic segmentation for the LDWS to solve the problem. To achieve this main goal or objective, this is the sub-objective to be accomplished. First is to create a benchmark ground truth class annotated dataset for unmarked road area. Then to train and build the unmarked road semantic segmentation using deep learning model. And then third one is to evaluate the unmarked road semantic segmentation performance. Then this is a general process flow of the unmarked road semantic segmentation. As you can see here, this is a dashcam as an input that will live stream the unmarked road and feed it into the mass RCNN deep learning model. Then this mass RCNN deep learning model will process the video by frame and it will output the semantic segmentation unmarked road. As you can see, here is the input. Right, this is a network architecture for the mass RCNN model. So how the process is being done inside the mass RCNN model is, for example, these unmarked road images are being fed into the CNN and it will extract the images features using a convolution operation and it will output the features map. So this features map will be passed into the regional proposal network to generate the proposal to identify the object location and object class inside the features map, and it will output the new features map that contain the object location and object class to be detected. Then this new features map have different size of dimension. So it will be passed into raw line to wrap it into a features vector in fixed dimension. So as you can see here, there is two parallel layers here. The first layer is fully connected layer, is where the features vector are being passed into this fully connected layer, and this layer will identify the object class and object location. Then the features vector also will be passed into the mask classifier to generate the mask of the detected object. These mask RCNN are developed by Facebook AI research to detect object in image while simultaneously generating a high quality semantic segmentation mask. So this is a process to develop a model that able to semantic segmentation the unmarked road. First, develop a dataset by collecting the unmarked road and from the Google image and YouTube videos. So this YouTube video will be extracted by frame and manual deletion to filter out the blurry scene and redundant scene. Then after that, annotate the dataset to create a ground truth benchmark. After the annotated dataset is done, I go for the model reconstruction. This is process where I train and validate the model using training and validate dataset. After the training and validate is completed, so I evaluate the model to test the model performance using test dataset. Then when I get the result from the model evaluation process, I do a model comparison to select the highest performance model. The selected model are deployed during the model prediction to semantic segmentation, the unmarked road. During the dataset development process, the total collected dataset is 2,000 unmarked road images with a various condition. And then from the 2,000 images, 80% are used for the model reconstruction process. Then that later split into two sets, which is training set 80% that equivalent to 1,200 dataset, and then Another 20% is used for the validated set, which is equivalent to 400 dataset. And then the remaining of total dataset, which is 20%, are used for testing, which is equivalent to 400 dataset. Then the total dataset that already split into 3 sets will be annotated using a VGG image annotator tools developed by Visual Geometry Group from University of Oxford. So this annotated process is to label the rod region in the image with a specific class name and location. So this is an example of the annotated images. So as you can see, this is original image before annotated, and then this ground truth images that have been annotated. So why the annotated images are important is to calculate the loss between the predicted and ground truth, to continuously update the weight of the model until the iteration is completed. During this model reconstruction process, to set dataset, which is 1,200 annotated training dataset and 400 annotated validated dataset are used to train and validate the mass RCNN model until the process is being completed. This session are conducted twice because we using two type of backbone, which is ResNet 50 and ResNet 101. So this backbone is known as a CNN that extract the features from the images using a convolutional operation that will output the features map that I already explained before, right? For model evaluation process, the remaining 20% of the total dataset, which is 400 annotated test dataset, are being fed into mass RCNN model to evaluate the performance of the model using a mean average precision metric with a 3 set of IOU setting, which is 50%, 75%, and IOU setting that varies from 50 to 95% at 5% step. Here, the model evaluation process is conducted twice because we use two type of backbone to extract the image features, which is ResNet 50 and ResNet 101. So, as you can see here, this color code represent the IOU setting here. Okay, for the first, the performance of the ResNet 50 for the first IOU setting is 0.85 MAP, and for the second setting is 0.8 MAP, and the third setting is 0.7609 MAP. And then same goes to the ResNet 101. For the first setting, it obtains 0.908 MAP, and for the second setting, it has 0.843 MAP, and for the third setting, it has 0.802 MAP. So, based on the Coco Corson theorem, MAP with IOU setting that varies from 50 to 95% at a 5% step is a preferred metric because it is a primary challenge set by Coco Corson theorem. So, here the final performance for the ResNet 50, which is the preferred metric, the MAP for the ResNet 50 in a percentage is 76.09%, and for the ResNet 101, the mean average precision for this backbone in percentage is 80.2%. Hypothesis can be made based on this performance result is where ResNet 101 able to semantic segmentation unmarked rod very well compared to the ResNet 50. To prove the hypothesis that been made, two samples of images being fed into the ResNet 50 and ResNet 101 for them to semantic segmentation the unmarked region inside the images. So based on this result, ResNet 50 able to semantic segmentation the unmarked rod, but not fully masking the entire region, as you can see here, and it also have an inaccurate mask prediction where it predicts this side rod as a rod while it is not. And then for the ResNet 101, it have a precise mask prediction where semantic segmentation the unmarked rod, and it also able to semantic segmentation the unmarked rod with an accurate mass prediction. So you can see here. So the hypothesis that been made is accepted where the ResNet 101 able to semantic segmentation the unmarked rod very well compared to ResNet 50, and ResNet 101 selected as a mass RCNN backbone due to the highest performance accuracy, which is 80.2%. The mass RCNN with a ResNet 101 as a backbone being deployed to predict the three categories of unmarked rod, which is gravel rod, earth rod, and unmarked paved rod. So based on this result, as you can see here, the mass RCNN with a ResNet 101 as a backbone confidently semantic segmentation the unmarked rod region with a confidence level above 98%. Then the selected model I used to develop this video demonstration. So for the first demo, the model is able to semantic segmentation the gravel rod with a bush at the side rod with a confidence level 99%. And then for the second demo, which is earth rod, the model also confidently semantic segmentation the earth rod with a cliff at the side of the rod with 99% confidence level. And for the third demo, the model achieved a confidence level 99% when it semantic segmentation the unmarked paved rod with a multiple object on the rod and the side rod. And what we conclude here, the mass RCNN model that we equipped with ResNet 101 have a performance accuracy 80.2% and it able to semantic segmentation the unmarked rod with a confidence level 98%. And the vision-based LDWS that equipped with this model able to assist the driver to drive in a rural road area and help to reduce the road fatality accident due to the lane exit. That's all from me. Thank you.
Right. Thank you, Mr. Harold, for a very interesting presentation. Inshallah, we'll have a safer journey, though the road is unmarked. Next time we hit the road. All right. Next, we move on to our second presenter from the Ural Federal University of Russia, Mr. Enter Mahamudo Hashan, Ebenezer Abozo, Shristi Shaha, and Abdullah Haidari. The title of the paper is Brain Tumor Detection in MRI Images Using Image Processing Techniques. So please be note that this is also a recorded presentation, so there will be no Q&A session for this presentation. Well, yes. Welcome. Second presenter.
Good day. On behalf of my co-authors and I present to you a paper written by researchers from 3 universities in Russia: Ural Federal University, National Research University, and the National University of Science and Technology. Our paper is entitled Brain Tumor Detection in MRI Images Using Image Processing Techniques. To begin our paper, one of the world's increasing illnesses is brain tumors, especially within Asian countries, as highlighted by the WHO. Brain tumors are converted into brain cancer in the final stage, and this leads to death. This can be treated and controlled by detection and its treatment in the initial stages. The best detection algorithm will always provide the best treatment. On one hand, manual detection of brain tumor from MRI images is time-consuming and prone to inaccuracies on the part of human domain experts. Fully automatic brain tumor detection methods are more accurate and low cost as compared to manual segmentation techniques. The main purpose of this work was to design a fully automatic brain tumor detection method developed using CNNs or convolutional neural networks from brain MRI images. Now, in order to solve our research goal, the methodology is as follows. In the primary stage, the proposed method has been tested and evaluated on our own data set from Bangladesh, which contains 1,660 observations, of which 69% of them are MRI images with tumors, and 31% of them are non-tumor MRI images. The image detection process consists of 3 stages. The first stage involves the splitting of data, which is based on random data splitting function. For detection, we divided our data sets into 3 phases, or 3 segments for training, testing, and validation. The training data set is for the training model, the validation is for the sample data, and the evaluation is for the model. For the second stage of the methodology, we handle the optimization algorithm. And the main purpose of optimization is to adjust the parameters to reduce wastage. And we adopted the ADAM, or the Adaptive Moment Estimation Optimizer. The third stage has to involve the CNN architecture. Now, as indicated in the image, this is the CNN architecture, which is the backbone of our research. We implemented the CNN architecture, which is made up of different layers, such as the convolutional layer, the activation layer, the max pooling layer, and the fully connected layer. Now let's dive into these 4 layers. The convolution layer is the first layer, and it works as an input, where the input image is treated as an array of pixels, which depends on the resolution and the size of the image. The rectified linear unit. The purpose of the rectify function is to increase the nonlinearity. The rectify function makes the images brighter and removes all dark elements, thus keeping only positive values. And the pooling layer, that's the third layer, basically reduces the dimensionality when the images are too large. So it converts 3-dimensional volume layers into 1-dimensional layers. Now the final layer, that's the fully connected layer. In the fully connected layer, 2 functions are performed. First of all, there is the flattening, and it is used to convert 2D matrices into 1-dimensional arrays using the Keras library. Secondly, the dense function is used, which takes the numerous inputs to give one output, and the dense function calculates the probability score for each class and classifies the final decision whether the input MRI images consist of tumors or non-tumors. For our results, as presented in the graphs and the tables, based on our proposed model, we split our augmented data into training, validation, and testing into ratios of 70, 15, and 15 respectively. There are 1,162 images for training, and 249 for validation, and 249 for testing of the model's accuracy. We trained the models for 30 epochs with a batch size of 10. The experiment was done using TensorFlow and Keras libraries in Python on a GPU having 2.3 GHz Core i5 processor with 8 GB of RAM. For the first 10 epochs, it is observed that the training loss was high and the training accuracy was low. After the 10 to the 20th epochs, the training loss and the training accuracy recorded approximately 0 and 1 respectively. The validation accuracy and the loss are varied without attaining stability. The validation accuracy is observed to be 0.92 to 0.94, and the validation loss varied from 0.5 to 0.6. We calculated the accuracy and the F1 score of the proposed CNN model as seen in the table. To summarize our work, brain tumor analysis using medical imaging is complicated, complex, and challenging, which can be categorized into pre-processing, post-processing steps. Based on our research, we highlight the following advantages. The first advantage is that it's cost-effective in the sense that, especially for developing countries such as Bangladesh, where medical treatment is costly and medical equipment is also costly. Doctors and experts are low in number, and as such methods will be able to contribute a lot to the medical world in developing economies by allowing doctors to monitor patients at a lower cost. Secondly, one other benefit is the time efficiency, that is the reduction in time for analysis and early diagnosis, as well as a better accuracy. Due to the limitations of compute power, we propose that for future research, higher computing power should be used for such intense research in order to get quicker results and better accuracy. Also, we propose that researchers involve or implement novel methods in answering this question to improve upon the process and the efficiency. Thank you for listening to our presentation.
All right, thank you for the presentation. So next, we'll move on to our third presenter from the host itself. From University Tun Hussein on Malaysia, UTHM. We will hear from Dr. Muhammad Syed Jawad, Muhammad Halil, Mr. Harun Nizam, Mahdin, Dr. Naif Abdul Wahab, Muhammad Al-Duis, and Dr. Salama Mustafa with the paper titled Recent and Future Innovative Artificial Intelligence Services and Fields. Without further ado, please welcome Dr. Syed Jawad.
Okay, good afternoon for all respected audience. Okay, and I'm Dr. Saeed Jawad from FSKTM CS Group. I would like to present this title paper regarding recent and future innovative artificial intelligence service and fields. So I would like maybe to go through the main points of the papers. Okay, so to highlight the main things about this paper. Okay, so this topic actually, I found it important because recently AI booming in a very fast pace due to the advancement we know, like in computing, advancement in the power of computing due to the GPU, due to GPU increased power, due to the capacity of the memory, data storage. So this allow more big data to be analyzed, and this boost the application of AI and make it like more successful, especially in digital transformation in many fields. And this is really increase the innovations and increase also many intelligence service. So this paper, like, it summarize this recent innovation with a highlight and focus of their increased market, especially in the coming few years, in the coming 5 years. So the main thing here, AI is main enabler of digital transformation. And very quickly here, if we talk about digital transformation, it means like we are going to micro segmentation and personal preferences. We are satisfying individual need. We are moving from segmentation previously to micro segmentation and even to preferences of individual, and we satisfy these preferences of the individual in real time, which is nowadays enable the digital transformation in, for example, marketing due to this AI. So this is like due to the advancement, maybe in marketing, we hear about smart conversational agent. So it can interact with the customer directly 24/7. And now it's getting very smart, so it can understand the context. So here again, micro segmentation, it means like we go up to the personal preferences. There are so many interesting applications of this in marketing, especially like for personal sales, okay? And it's adopted widely recently in marketing. Another very promising field is AI in healthcare or in health industry. So with increased power of AI, now medical diagnosis can achieve much more better. Even some estimate that in coming few years, it will be better than human, doctor as a human, AI can overcome them. And they claim that because like a human can diagnose based on their experience of maybe 200, 300 picture, but AI maybe can treat million of pictures and classify exactly based on data consider like 1,000 or million. So diagnosis is getting more better. And especially if we combine that with electronic health record, so this will boost personal medication significantly in the coming few years. Okay, in finance and banking, this is another very interesting field where AI playing very critical role also in finance and banking. We can imagine scenarios like automated bank loan. There is no need like to wait for very long and for this tedious process. The things can be done like almost in a few minutes. So it can be approved, the approval of your loan. And also payment options. It can be attached according to the personal preferences. So this is honestly also like giving a huge revolution for finance and banking. We are moving from very near, previously in previous year, like from the nearest like 2-3 years previously, from facial detection and recognition. We are moving forward now, and it will also witness a huge advancement in emotional or emotion AI. So we're not only able to capture the face and identify the face, even we can capture the emotion in the face. And there are a lot of innovative application of this regarding like security, monitoring the attention of the student, monitoring the attention of the staff. Maybe there are a huge benefit of monitoring the emotion state of people in real time. So this is one field. Another very new field, which is creative artificial intelligence. So this field is very new, and now it's like progressing very fast. We can imagine like the AI can generate a new piece of music or new piece of painting based on some style feed to the AI. So we can imagine that we feed AI like system with like 200 painting. So it will analyze the style, and it can generate a new painting based on this style, which is pretty amazing, really. It can produce even like new music. Very important AI field now also like witness considerable attention is explainable AI. AI is always criticized that it's like the internal process is opaque and is not transparent. So even the accuracy sometimes reaching like over 90%, but it's still like not acceptable in some field like medical. So like which any error here it will be very fatal. So in order like to reduce the risk, mitigate this risk, so AI should explain why the decision being taken in such criteria or why this classification being done. So it's up to the human to approve later. So this is increasing the trustworthiness and increase the transparency of AI, especially in medical field and in some critical business application like investing. So where even like over 90 is not acceptable, we need like 99 or more, and accuracy here is the main concern. The last field I want to highlight, which is responsible AI, which is like ethical AI. So this is like mainly in use in military use, and mainly I said like there are other also fields which responsible AI playing a critical role. What we mean responsible here is like accountability. So if there is a mistake, who will take charge of this? And like from the system, are they the developer or so? The responsible AI highlighting accountability, also transparent. It explains why the decision taken. Plus, it's secure. It's secure. They're accountable, okay. Privacy also here is achieved or is concerned in responsible AI. So this is like the latest things also in AI, like coming after. So we can imagine from AI to explainable AI to even now responsible AI. As a conclusion from all these fields and innovation and new service, we can say that AI extend human creativity in a very big manner. There are some issues. Is AI itself innovative, creative like a human? That's still like in a big doubt. Because like we cannot imagine AI producing something without like supervising the system with some style, something. But what's clear now, maybe in future it can be like original creative machine. But what's clear now, it's extending and accelerating human creativity and innovation in a really very considerable and amazing base, okay? So I think with that conclusion, I can end up my presentation here. Thank you very much, and maybe I can also, if you have any question or something, maybe we can have a Q&A session for this.
Right. Thank you, Dr. Zaid, for the presentation. Very interesting paper. So we have creative AI, responsibility AI, and So we are waiting for any questions from the participants. While waiting, maybe I can ask you one question. Okay, with the development in AI that much, Dr. Zaid, is there anything that we have to look forward for in terms of the regulations and also the ethical parts of AI that we have to overcome? For example,
Do we give the machine like the decision to fight a human? So this raises like ethical issue. So nowadays, now it's a big like efforts to regulate that and put that in like regulation, especially for, let's say, military. where they use a lot of robotics and automated machine and intelligence battlefield. So the regulation is ongoing now. It's like many research around the world now trying to regulate AI. So this is like recent effort, and it's ongoing efforts also.
All right, interesting. All right, thank you, Dr. Said. I guess that will be all the questions we have for now. So now we move on to our fourth presenter from the University of Tun Hussein on Malaysia, UTHM also. The authors for this paper is Dr. Muhammad Halil Muhammad Said, Dr. Muhammad Halil, Dr. Muhammad Said Jawad, Dr. Haruniza Mahdin, Dr. Naif Abdul Wahab, Muhammad Al-Duais, and Dr. Salama Mustafa. The title of the paper is Industrial Digital Twins Powered by AI Solutions for Enhanced Product Lifecycle Development. Without further ado, please welcome the fourth presentation.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Hilayil. I am a PhD researcher at UTHM University. And on behalf of my colleagues and the authors of this paper, I am presenting an overview and the application and the potential of using industrial digital twins powered by artificial intelligence solutions for enhanced product lifecycle development. Today, the whole world is living on the impact of the fourth industrial revolution, which consists of different modern technologies that integrate the physical, digital, and biological worlds together as a kind of digital transformation. Amongst the different modern technologies, I would mention here the artificial intelligence and the digital twin, which are very important in the context of manufacturing processes. Artificial intelligence allows data-based modeling of complex dynamic systems and the use of these models for regulation and decision making. While the digital twin in itself is a kind of a model of functions of an object, the components of which results from the product development process. Therefore, nowadays we can't imagine smart factories without speaking and integrating innovative technologies such as automation technologies, digital twins, and artificial intelligence. Now, what is the digital twins? Digital twins are the virtual representation of physical technical objects which can already exist in the real world or planned for the future use. It's a kind of 3D model of machines, products, or systems such as factories or organizations or even humans with their properties, conditions, and behavior. And here, very important to distinguish between a pure 3D model and the digital twin, as mentioned or as required to call a 3D model a digital twin is to have data transformation between both objects in real time. That means the data from the real object has to be transferred to the virtual one and vice versa. Therefore, digital twin uses IT sensors to transfer the relevant information and to store these real-time data and map it with the real object. It's the digital twin actually is used widely in the industry for designing products, testing machines, virtual commissioning, production, and maintenance. The artificial intelligence here is very important in the product life cycle because it can be used to facilitate the development of technical solutions as well as the maintenance and service for industrial machines. Very essential criteria for successful artificial intelligence applications lie in the amount and quality of data which is used to train the algorithms to take decisions. That means we need data to train the artificial intelligence applications to take decisions. And this is one of the biggest problems we are facing currently is the availability of data. Therefore, to solve this problem in a less costly way, digital twin is used because it's create a simulated data to train the artificial intelligence models. And artificial intelligence can also take advantage of digital twin, since digital twin can create virtual environment with virtual data for machine learning test scenarios. That means it can be used as a test bed for artificial intelligence models and algorithms. Now, speaking about one of the most area of applications for digital twins nowadays is in the production technology. Entire product life cycle divided into 3 stages: the design stage, the production stage, and the service stage, as you can see from the picture here. And every one of these stages is divided in subcategories or phases, where we can find the digital twin used over the entire life cycle of a product. Now, speaking about the role of digital twin in production design phase, which is very critical process because it's very expensive and the company needs to build and develop a product without knowing the results in advance. Therefore, they build their own prototype, one and second prototype, and this is very expensive for them. A major challenge here in this process of mechatronic systems, in particular, the interaction between mechanics, electronics, and IT. And these can only be tested after the hardware configuration has been completed. That means after they have built the real object. Here, the digital twin is the best solution, as it can be tested, and all these systems or all these criteria can be tested virtually in advance without the need to build a real prototype. In this case, the artificial intelligence algorithm takes these data received from the digital twin and used it to take decisions or to train data models in advance. And through this process, variables can be tested to obtain the best setting and desired characteristics without spending a lot of money on prototyping. And this will, as I said, reduce the cost and the risk by the development process. So many can be found in the industry nowadays. Take an example here, for example, the Robert Bosch factory in Germany. The company used the digital twin to reduce the internal startup time and to obtain the greater safety for planning using digital twin. As you can see, they have built their own digital twin, which reflects the real machines. This helped them also to overcome the limitation of the current installation space, because the digital twin is a virtual copy and can be used to implement different automation solutions without the need to build a real one. It has been also used as an evaluation tool, simulate how the robots work in different situations and to avoid collisions, for example, which cannot be tolerated, for example, by using in real case or a live product. In the car manufacturing industry, we find, for example, Maserati, which was able to reduce the production time and manufacturing cost by approximately 30% using digital twin. Hyundai and Kia's, although they build only also their own virtual digital twins to simulate operations. An example of the usage of digital twin here to overcome, for example, the complex and costly wind tunnel testing process, which is necessary to improve and optimize the body aerodynamic of a car. A new company called AutoX, which is specialized in autonomous vehicle company, is using digital twin inputs to form a coherent picture, which is used by deep learning algorithms to enhance the design process and to optimize the rendition's realism. Now, speaking about the product build phase, which is very complex because there is a need to have a component which can handle all kinds of information, such as information flow, materials, energy consumption, and to simulate the interaction between all of these. Therefore, digital twin can be used here in this case as a digitally mapped or digital map between the real and the virtual one, can be automated and tested before even the software, for example, put into operation. This is what is called virtual commissioning. Through virtual commissioning, component failures can also be simulated. The simulation can be run at different speeds to test the performance of the machines, and other quality or safety problems can be identified and minimized or eliminated, and the product can be customized to match the customer needs. Now, examples for this, we can find it, for example, by the company Krones and Bosch Packing Technology, which they have used digital twin and optimized the commissioning time for the machines by testing, for example, the controller software before the system prototype has been built or manufactured. And this saved for them a lot of time and money. Another examples, for example, can be found by SEW Eurodrive company, which is leading in manufacturing gearboxes and drive technologies. They have reduced the time required for planning, construction, and commissioning of gearboxes from 6 months to 2 weeks, according to the manufacturer website. Now, in the service phase, we find the digital twin plays the main role here, as in this phase, monitoring, diagnostic, and prognosis of planets is the main service which is provided. Digital twin with AI technology can analyze failure probabilities and make prediction for error and failures in the system even before that happened. That means it can predict which error may occur in any kind of situation. Here, the machine learning plays the main role, as it's a kind of behavioral train which is used to differentiate between wanted and unwanted behavior and drive prediction from individual behavior patterns. And therefore, it's being used, the smart digital twin, to provide suggestions for predictive maintenance to avoid future failures and all corresponding, for example, downtime of the factory. And now an example here, we see a good example can be found by Beijing Technology Company, which has developed their own smart digital twin for managing and monitoring power plants. It's used for many purposes, and it provides a great features for all customers, such as real-time monitoring, visualization, online precision diagnosis, and can be used also for training. And it helped the company to reduce operation costs, increase safety, and improve the planet operation efficiency. Another examples here by KSP manufacturer, pumps manufacturer, which is use cloud-based condition monitoring system to remote maintenance their own pumps. The data from the real object is sent to a database, which can be evaluated by an application as digital twin to provide an efficient monitoring system and detecting all kinds of malfunctions before it happened even, and this way to reduce the cost and to allow remote monitoring of their pumps for their customers. As a conclusion, the digital twin with artificial intelligence solutions are the key enablers technology for Industry 4.0, as they offer optimization possibilities in all kinds of industry, and they help designers and operators to save costs, to optimize their products, and to master even the development complexity and better secure both the development results and changes. Therefore, it has a lot of benefits and advantages for manufacturers and operators to be used and implemented. And however, there is still so many challenges which require more researches and innovative approaches, and this can be seen as highly beneficial for researchers to decide in their intended contribution how to use this technology and in which phase can this technology be used. Thank you for your attention.
Okay. Thank you, Doctor, for the presentation. So now we move to our fifth presenter from the University of Technology Mara, UiTM, Malaysia. I would like to welcome Mr. Adi Aiman Ramlan, which is co-authors for this paper is Dr. Aziza Mahali, me myself, and also Dr. Rizanawati Osman, to present the paper titled The Implementation of Reinforcement Learning Algorithm for AI Bot in Fighting Video Game. Please welcome.
Everyone, my name is Adi Aiman Ramlan and I will be the presenter for this paper that was titled The Implementation of Reinforcement Learning Algorithm for AI Bot in Fighting Video Game. The other authors that also contributed in the writing of this paper were Dr. Aziza, Madam Nurziatul and Dr. Rosiana Wati. So for the introduction, artificial intelligence and machine learning have become more and more advanced. To test the AI algorithm and models, video games are a natural and a useful medium since this virtual environment are safe and controllable. And AI in games interact with players, whether it is there to challenge the player or helping the player throughout the gameplay. And reinforcement learning is one of the machine learning methods that was inspired by the behaviorist psychology, specifically on the way humans learn to make a decision based on a reward and sanctions gathered by their behavior in the environment. Next, I will explain about the problem statement of this paper. And the finite state machine is a common technique used in developing AI in games, which makes use of a predetermined action for each situation. The problem with the predetermined action is that the scripted behavior can be predictable and easily be exploited by human player. This can cause the game to have a repetitive gameplay, which leads to the player to lose interest in the game, since the player will know how the AI will behave. So this is the methodology that was used for this paper. The research framework consists of three main phases: game development, model development for the agent, and analysis of the result. For the game development for this project, it was developed using Unity game engine and C# programming language. As you can see on the figure on the slide, it's actually the Unity game engine. As you can see, there are game environment, also game objects, and there's a C# script at the bottom and also a file directory. For the model development for the agent, we use the Unity ML Agent Toolkit. Unity ML Agent make use of a TensorFlow and Python API to train the agent. As the figure shows, from the game environment, the TensorFlow and Python API will train the model and generate the model. And we took that model generator and embedded into the agent in the game. This is the architecture used in this project. For the learning process of the agent will observe the state from the environment. In this case, it takes its own and their opponent's health, stamina, and distance between two fighters as input, and gives a particular action such as attack or movement as output. Then the action is performed in the environment. If something positive happens as the result of the action, like hitting the opponent for example, then the environment sends back a positive response in the form of a reward. If the health of the fighter deducted because of getting hit by the opponent, then the agent receives a negative reward. And based on the reward received, the current policy will be compared to the new policy and will decide which policy to keep for the agent. And the proximal policy optimization algorithm was used to update the policy for the agent. For the analysis phase, the model will be analyzed based on cumulative reward throughout the iteration. This method is suitable to implement because it will show the bot learning convergence in the given environment. Changing the parameter value are also important to train the network to achieve the expected performance and also to accelerate the convergence of the learning model. The parameters that will be manipulated in this project are the number of neurons in the hidden layers and also the learning rate. This is the table for the parameter setting used for this project. There are changes made at the learning rate and neurons in hidden layers. It is shown as a highlighted area in the figure. This is the screen capture for the agent training process. The reward was given by the reward function that was self-designed. In the terminal, it shows the agent action steps, time elapsed, mean reward, and standard deviation of reward for every 10,000 steps the agents took. After the training was complete, the ML Agent Toolkit will generate a graph in the TensorBoard for the analysis of the training model. The y-axis represents the cumulative reward and the x-axis represents the number of steps the agent takes. 3 training cycles will be done for each parameter setting and the average will be used for the final analysis. This is the result for this project. As you can see in the figure on the left, it shows that the training model with parameter setting 2 have the best result compared to others. Lowering the learning rate to 0.0003 managed to increase the learning convergence point for the agent, and it stays above 140 line. Because the learning rate is smaller, the step the agents need to take before convergence is longer, which is at 70,000 steps. It can be concluded that the learning convergence for the agents in this project environment is located between the cumulative reward value of 140 to 120. So this is the end of the presentation. Thank you for listening and also thank you for this opportunity.
All right, Alhamdulillah. Thank you, Adi, for the presentation. So next, we'll move on to our sixth presenter from Telkom University Indonesia. We would like to welcome Dr. Alvin Nofurkon, Dr. Burhanuddin Dirgantoro, and Dr. Kasih Setyaningsih. Sorry if I mispronounce their names. Their paper is titled Predict Buy and Sell Time for Stock Price Using Convolutional Neural Network and Long Short-Term Memory. Without further ado, please welcome presenters from Telkom University Indonesia.
Buy and sell time for stock price using convolutional network and long short-term memory. My name is Alvin Nofurkon. I am from Telkom University. Let's get started. In our research, create a model that can forecast what should the user do for buy, sell, or keep in stock price based on computer science and artificial intelligence. Investor or trader should have solid analysis skills like fundamental analysis, technical analysis, and sentiment analysis. They should have a basic about efficient frontier, mean variance, optimizations, Sharpe ratio, CIPM, and diversifications, and even more. There's no guarantee always getting profit even already analysis. So we want to give trader or investor a new point of view based on computer science and artificial intelligence to help determine when to buy or sell at stock price after analysis. A new point of view will behave to gain more information about what analysis to do more about your trade. our scope, we'll focus on computer science and artificial intelligence point view. So we didn't bring in our scope for technical or fundamental analysis. In machine learning and deep learning, we can use so many models, but because we were dealing with sequence data and historical data, we will use LSTM and CNN for our main model, and statistical approach. Before we go in deep into our research, we're gonna start from stock price. Stock data generally have a SIG indicator: high, low, open, close, adjusted close, and volume. The SIG indicators have their understanding of the stock. High is the highest bid price when trading takes place, and then low is the lowest price when trading takes place. Open, the initial opening price. Close is the closing price when trading ends. For the volume is the number of the how many transactions we were made on the stock. To read a candlestick chart, the candle's color is green when the open is above and the close is below. Stock price can conclude that the stock is showing an increasing price. The candle's color is red if open is below and the close is above. The stock in at a discrete price. High and low are determined by volume. Then we next to the return. Return is how many return you will gain on your investment. This is our example. We have initial investment price and sell price. So for the formula, R or return is equal with a price minus previous price, and then divide by previous price. So in our example, you will get the return is 25%. Then long short-term memory. Many development of deep learning model have been successfully created in problems related to data sequence such as speech recognition, music generation, sentiment classification, DNA sequence analysis, machine translation, video activity recognition, and named entity recognition. In such case, the artificial neural network or DNN model can be said to be incapable of dealing with problem like this, because if we take an example in sentiment classification case, sometimes the number of character in the text is different, plus some word that have many meanings. So the INN or DNN model is not suitable for use as a solution to the sentiment classification case. In long short-term memory, we have three parts: forget gate, input gate, or people say update gate, and then the last is output gate. For furthermore, you can see in towarddatascience.com illustration with to LSTM and GRU. And then convolutional neural network. Convolutional neural network, or abbreviate as ConvNet, is one of the deep learning architecture. ConvNet is a technique where input will be performed is convoluted to obtain edge on an input. In this case, and it can be one-dimensional signal and sequence, two-dimensional image and audio spectrogram, then three-dimensional for video or volumetric image. Convolution in one-dimensional is multiplied by the input linear time invariant or sequence data is x, and the kernel's signal is w, or filter. The total number adjusted to the length of the kernel signal is n, then shifted to the right by stride. So this is a formula for conv one-dimensional. Okay, in our modeling, we use a grid search to find the best parameter in our case. For artificial neural network, we will use 64 neurons and using optimizer Adam. For convolutional neural network, we use 64 neuron, then using optimizer Adam, and the size of the kernel is 5. For long short-term memory, we use 64 neuron and use optimizer stochastic gradient descent, and then we combine CNN and LSTM using parameter 64, then optimizer using SGD, then the kernel size is 5. Okay, and then we modeling our case. If we using high, low, open, and closed data to forecast the next stock's price, we will see that if we use visualization for data stock price for open, high, low, and close, having a non-normalizations. This is not Gaussian distribution. And then when we train, we can see that the mean absolute error is very big, and the minimal of our train is 230. And then if we still using that to predict 10 days, we can see in here for all model we have like ANN, RNN, CNN, and LSTM, having a bad predictions to predict 10 days for further. So if we use return data to predict the time to buy, sell, and keep, we can see that the return data is come from normal distribution or Gaussian distribution. And then if we plot them using probability plot, we can see the data point is near with normal distribution line. Then because our data is come from normal Gaussian distribution, we can predict the time when to buy, sell, and keep. In our research, we got for ANN for data train like this, and CNN like this, and LSTM, and with CNN with LSTM for data training, and for testing it's like this. For the conclusion, so to predict stock price based on return, the LSTM model has better performed than CNN, ANN, and the CNN LSTM merge model, where optimal parameter are in neuron 64 and optimizer is Adam. Growth and prediction based on the hype, low, open, close stock price. In that case, the prediction obtained are not so good because the data does not come from a normal distribution. Stock price will continue to move out, meaning that if we use very long data, it will not predict prices. That's all about our project. That's all my project. Thank you very much.
All right. Thank you for the presentation. Okay, now we move on to our next presentation, also from Telkom University Indonesia. This presentation, this paper is produced by Dr. Doni Tontiardo, Dr. Burhanuddin Dirgantoro, Dr. Kasih Setianingsih, and Dr. Herdian Roberto. The title of the paper is the design and the implementation of computer-based aptitude test for computer engineering with fuzzy algorithm. All right, so without further ado, please welcome our seventh presenter from Telkom University Indonesia.
My name is Doni Tontiardo. Today I'm going to present you about our journal. The journal itself is called Computer-Based Aptitude Test Development for Computer Engineering Student. The first section is System Model and Design. This part is called aptitude mapping. Aptitude mapping is the process of translating job descriptions. The job description itself is obtained from the onetonline.org into 9 aspects of aptitude, namely visual, numerical, verbal, sequential, spatial, 3D, system, vocabulary, and figure work. This aptitude mapping process is done by the psychologists. As an example, we'll be using the computer hardware engineer job description. This is the results from the aptitude mapping. This result will be used as the parameter in the fuzzification section. This is the flowchart for the system. This flowchart is telling how the user interacts with the system. First thing, the user will inputting data or registering in the system, and then the user will take the aptitude test. After the user taking the aptitude test, the system will perform the assessment. After the assessment is done, the system will perform aptitude mapping with the fuzzy algorithm. The output from the system is the map aptitude. Before we're going to the fuzzy algorithm, the crisp value from the system must be converted first. This is the scoring and the converting section. This table shows the aptitude aspects with their classification. We get this table from the book. This table shows you that the maximum percentage and the score per item that you get from our test. We can implement the second table into the first table and get this table. As you can see, in this table, there are some flaws because there is a gap between the classification itself. To remove this gap, we must search the median value from the classification and break down its boundaries. After searching the median and breaking down the boundaries, we get this table. As you can see, there is no more gap between the classification. This is the fuzzy system model. The first thing is the crisp input will going to the fuzzification section. After that, it's going to the fuzzy inference system. In the fuzzy inference system, we're going to apply the rules that was provided by the expert. And After the fuzzy inference system, we're going to the defuzzification to get the crisp output back. This is the fuzzification section. In this fuzzification section, we'll use the trapezoid and triangle membership function to convert the crisp value into the fuzzy value. We'll be converting every aspect of the aptitude, and as an example, we'll use the computer hardware engineer again. This is the fuzzy inference system. The rules for fuzzy inference system is provided by an expert in this field. V is stand for visual, Nu for numerical, V for verbal, C for sequential, SP for spatial, 3D for 3 dimension, SY for system, VO for vocabulary, and V for figure word. G stands for good, S for sufficient, B for bad, and then H is for high, L is for low. For the fuzzification itself, we're going to use the expert parameter to convert the fuzzy value into the crisp value again. And the method that is used in this defuzzification is the centroid method or the center of gravity. This is the video of the demonstration. I will send the YouTube link for you. Now for the results and analysis. This is the results from the website. As you can see, the most acquired specialization is on the computer network specialist, and the least acquired specialization is on the computer hardware engineer and database administration. There is a null data caused by the unfinished work. The data itself is still valid because it's proof the algorithm succeeded in making decisions correctly. This is the system accuracy. We have valid data of 62 data, and the invalid data is 0, and the total data is 62, which make the system accuracy is 100%. For the validity test itself, error count is higher than the error table, and the significance is lower than 0.05. So the conclusion for all these tests is valid. As for the reliability test, the reliability coefficient is higher than the parameter, which is 0.717, which make the conclusion is reliable. The conclusion: aptitude test application is going well with the alpha test results of 100%. The aptitude test itself is proven success by providing the interest or the specialization by the accuracy results of 100%. And there are some students that is interested in the computer network specialist, as many as 18 students, followed by computer programmer, 11 student, computer system analyst, 9 student, computer hardware engineer, 7 student, and the database administrator as 6 student. The application has an average beta test value of 85% with the conclusion very easy, and also has passed the reliability and validity test. Okay, that's all for today. I may thank you for your attention. Good morning. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. My name is Doni Tontiardo. Today I'm going to demonstrate how the website works. The website itself is called CHEAT. It's shortened for Computer Engineering Aptitude Test. This is the homepage. The homepage has a computer engineering symbol and take the test button. You can click it. This is the login page. The login page requires a student ID and the password. But if you haven't got any account, you can always register. This is the registration page. It requires a full name, student ID, age, and password. But because I already has an account, so I'll use mine. This is the login page after you login or after the user login. It has a see your result button, and it has a take the test button. I'm going to take the test. This is the information page about the test. The test itself consists of 9 sections. visual, numerical, verbal, sequential, spatial, 3D system, vocabulary, and figure work section. These 9 sections will going to be used to determine the aspects of the aptitude. Now this is the instructional page of the visual section. It has an instruction about the page and how to answer the question. This is the visual section test page. It has a multiple choice answer. After the visual section test, we're going to the numerical section. This is the numerical section instructional page, and this is the test page. The numerical section has an SI type questionnaire. This is the verbal section. This is the test page of the verbal section. It has a multiple choice answer. This is the sequential section instructional page. And this is the sequential section test page. It has a multiple SI for answer. Now this is a spatial section instructional page. It also has a multiple SI answers. This is the 3D section instructional page. This is the 3D section test page. It has an SI type question. This is the system section instructional page. And this is the system section test page. It has a multiple SI type of question. This is the vocabulary section instructional page. And this is the vocabulary section test page. This is the figure work section instructional page, and this is the figure work section test page. Now, this is the results page. This is the time and the date from when you working on it. This is your results. Your correct choice will be shown in this table. Now, this is the progression graphic. This will show you how much you have done, and the progression graphic will be converted into a potential value. The potential value will be shown in this potential graphic. And beside the potential graphic, this is the computer and IT graphic. This is the reference from the book. And the last part is the output. The output is in the form of specialization that has the highest compatibility value. In this case, the highest compatibility value is in the computer hardware engineer specialization. Okay, thank you. That's all for the demonstration of the website. Thank you.
All right. Thank you, Mr. Doni Tontiardo, for the presentation as well as the demonstration for the project. All right, so next we move to our eighth presenter from Telkom University Indonesia. We would like to welcome Mr. Adli Farhan Ibrahim, Dr. Sena Pahlavi Ristiawanto, Dr. Budi Irawan, Dr. Kasih Setianingsih, with a paper entitled Micro Expression Recognition Using VGG19, CNN Architecture and Random Forest. Please welcome Mr. Adli Farhan Ibrahim.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself first. My name is Adli Farhan Ibrahim, and I'm from Telkom University, Bandung, Indonesia. In this video, I will explain to you about my final assignment project. The title is Micro Expression Recognition using VGG19, Convolutional Neural Network Architecture, and Random Forest. Okay, in this video, there is 3 outlines that I will explain. The first one is scopes, problems, and solution. The second one is methods, and the third one is result and analysis. Next, I will explain to you about scope, problems, and solution. I will start from problems and solution first. The problem is micro expression is a hidden expression of human. This happen in very short period of time. This is so difficult to capture with only bare eyes. So in this research, I want to develop a program that can do analysis and or recognize micro expression automatically. The problems can be divided by 2 major points. The first one is how to classification in micro expression from SMIC database with good accuracy. The second one is how to evaluate performance of the developed system. And the solution we offer from the problems earlier is the first one, develop a system that can analyze and recognize microexpression with VGG19 as feature extraction and random forest as classifier. The second one is do comparison for the testing. This will split with variable training validation. The ratio is 50 by 50, 55 by 45, 60 by 40, and so on. It will multiply by 5 until it's reached 90 by 10 percentage. The last one, I will explain the scope. The scope for this final assignment is the first one is system that will be created is only used to analyze or recognize microexpression. Second, using Python as programming language. 3, using Jupyter extension file or .ipynb. Fourth, using VGG19 as feature extraction. Fifth, using random forest as classifier. And 6, using SMIC-crop database. 7, testing is done by splitting the database with ratio 50 by 50, 55 by 45, and so on. Like I explained before. And the last point is testing is also done by get the accuracy, precision, recall, and F1 score value for every ratio using confusion matrix. And I will next I will explain to you about the SMIC-crop database. This is the database which I use in this final assignment project. This SMIC there is 3 different camera for the capture the image. There is near infrared. It is with so the result is with infrared. The result for the picture is in black and white color, and the second one is FIS. This is visual camera like actual camera, and the last one is HAs. This is a high-speed camera. So this is can capture video from the really high frame rates per second. This make crop database is after process for the SMIC raw. So the database is already cropped in the face. So this is so very helpful in our works. Also the SMIC is have 3 labels. The first one is positive, the second one is negative, and the last one is surprise. Okay, there is our methods in general. There's our method in general that I will explain to you. The first one is database is going processed with the pre-processing process. After that, we will extract the feature using VGG19, and after get the features, we will do the classification with random forest. This is in general. So I will explain to you again what's going on in the pre-processing. The first one, there is in program for loops to fill empty array with received image. After we fill the empty array, we need to change the data types of the array with NumPy API function array. So the data types will be NumPy array. Then after we change the data types, we need to split the data with the percentage I explained before. And the third process is encode the target variable. I forget. In program for loops, we also already get the label for every image. So after encode variable using one-hot encoding, and there is the illustration below. Before one-hot encoding, the label is positive, negative, and surprise, and after one-hot encoding, the label will be integer 0, 1, and 2. After we encode, we need to normalize the pixel we have obtained before. The NumPy array which we obtained earlier will be divided by 255. This will normalize value in range 0 to 1. there is the final process for the processing, and after that we will do feature extraction. Feature extraction is done by using VGG19, and I will show you the configuration layer after that. And there is three layers, main three layers: conf2d, pooling, which is max pooling, and flatten layer. Okay, here's the configuration for the layer. Okay, next I will explain you what's going on inside the layer. From the configuration earlier, the program will use filter size 3 times 3 and using 0 paddings. The layers will use default stride value, which is 1. So the convolution process will move one by one for each value. Okay, there is the illustration in the convolution layer. So in this matrix, there is a 0 padding in here, and the stride value will move one by one, like default value is 1. Okay, after that, the value will go to hidden layers or activation function, where there is ReLU activation function. Basically, ReLU will pass value which is bigger than 0. So when every value is bigger than 0, the return value is equal to value. So for example, the value is 1, the return value will be 1. If the value is smaller than 0, the return value will be 0, or there is minus. So for example, if the value is -1, the return value will be 0. And there is the second layer is pooling layer, which is max pooling. The result will from convolution layer will be filtered with maximum value. There is the illustration for the max pooling. And the last one is flatten layer. The final layer is flattened. This will reduce the dimension of the value. And after that, after we get the feature we got earlier will be classified with random forest algorithm. There is the illustration. So there is the feature for the what we got earlier. In this process, the feature will be splitted by some by difference count, and every feature that the algorithm split will doing classification process for itself. So after the classification process itself is done, every feature that have splitted before will do the majority voting, and the majority voting is the result. Okay, the final output is classification result, and there is the illustration from the program. So this is this program can predict the micro expression correctly. Okay. The rest is result and analysis. There is a result for every percentage. As you can see, there is a 50 by 50, 55 by 45, and so on. Like I explained before, it will multiply by 5 until it reach 90 by 10. There is the last one. After we get the performance from the every ratio, we need to evaluate the best performance from every value. And after we evaluate, there is the best performance that we have. There is split for the 90 by 10. This is the best performance that I have. That I got from the every split. And after that, we will evaluate the hyperparameter in the random forest, which is an estimator. An estimator is in random forest is like the count of the tree in the algorithm that we will use. So to evaluate the initial value for the an estimator is 10, and we need to evaluate which value is the best. The value we will evaluate will be multiplied by 10 again. So the first one is 10. There's the initial value, 20, 30, 40, and so on until it's reached 90. There is the result for the near database, for the near camera. There is the result for the fish camera. As you can see, the near and fish have already has the best parameter, which is 10. So this is 10. There is also have the best performance for the near and fish. So, but we need to evaluate for the HS. As you can see, there is the initial value, and you can see the best performance that we got in the HS camera is 30. So the 30 need improvement and change its an estimator to value is by 30. Okay. There's the conclusion and recommendation. The conclusion, the first one is, in this research, the writer has been successfully developed system analysis micro expression recognition with CNN architecture VGG19 as feedback section and random forest as classifier. The result is accuracy value between 98% to 100%. In this research, the writer also successfully to make comparison and performance evaluation within percentage, 50 by 50, and so on. And the recommendation is, there is 3 recommendations. The first one, doing deployment of the trained model to doing real-time detection using available device. The second one is the deployment can be done and implemented to website-based application or even mobile-based application. The last one is adding more memory to hardware, because the more data will be processed, the more memory will be needed. Okay, I think that's all. Thank you very much.
All right, thank you, Mr. Adi Farhan Ibrahim, for that presentation. So, Alhamdulillah, we move on to our last presenter for today for this session, Intelligent Systems. We would like to welcome the authors of the paper titled A Concise Review of Deep Learning Deployment in 3D Computer Vision Systems, wrote by Dr. Farouk Sijah Shakwi, Dr. Lukman Uda, Dr. Muhammad Ahmed Jubar, Dr. Mustafa Hamid Hassan, Dr. Muhammad Helmi Abdul Wahab, and Dr. Salama Mustafa. So all the authors are from University Tun Hussein on Malaysia, UTHM. So without further ado, I would like to welcome Dr. Farouk Sijah Shakwi to present the paper.
Assalamu alaikum. My name is Farouk Sijad. My presentation paper is a concise review of deep learning development in the 3D computer vision system. Abstract deep learning has pushed the limit of what was possible in the demand of digital image processing. This paper has been computed the traditional computer vision and DL for typical application. This paper will be analyzes the benefit and drawback of each approach. Combining traditional computer vision technique with DL has been popular in emerging domains such as panoramic vision and 3D vision. Introduction. Deep learning is used in the domain of the digital image processing to solve difficult problems such as image colorization, classification, segmentation, and detection. DL has domained the domain over science because distinctly better performance computer to traditional method. Is DL making traditional computer vision technique obsolete? Has DL supported traditional computer vision? Is the style needed to study traditional CV technique when DL seems to be effective? 3D vision, traditional computer vision. Conclusion. A lot of computer vision techniques invented in the past 20 years have become irrelevant in recent years because of DL. This paper has been combined traditional CV and DL for typical application and discussed how sometimes traditional CV could be standardized and as a limited learning to be in the situation where DL work for the specified task. The paper also highlighting some area where traditional CV technique remain relevant, such as hybrid approaches to improve the performance. This paper is the reviewed have the traditional CV technique can actually improve DL performance in with range of.
Alright, Alhamdulillah. With that, we have come to the end of this session. Inshallah, we're going to have lunch break until 2:30 a.m. and we'll continue with another session this afternoon, the Internet of Things track. Alright, with that, have a nice break and then we'll see you again at 2:30 p.m. Thank you.
For 60 years, University Technology Mara, or UITM, has been the place for acquiring knowledge and developing capabilities. From a training center to now a vast network of universities, UITM has campuses and faculties all over Malaysia. UITM allows for the pursuing of goals and earning a degree in any field of choice, with a mission to enhance the knowledge and expertise of Bumiputras in all fields of study, through professional programs, research work and community service, while upholding moral values and professional ethics. Nestled amidst the greenery and some of the most scenic areas in the country, each university campus is strategically located in places where their presence inevitably provides an economic boost to the local community. UITM pledges to provide maximum opportunities to pursue professionally recognized programs of study in science, technology, industry, business, arts and humanities. University Technology Mara offers quality education at all levels of study, from foundation to postgraduate. The university has always been at the forefront in science and technology, as well as in management. It is a place where talent, skills and excellence are nurtured. UITM has a mission to empower the indigenous people through the provision of higher education in accordance with Article 153 of the Malaysian Federal Constitution and Act 173 University Technology Mara Act 1976. Duli Yang Maha Mulia, Sri Paduka Baginda Yang di-Pertuan Agong is the Chancellor of UITM by virtue of his status as the King, as provided for by the law. UITM has established 8 centers of excellence and 1 high COE to enhance the scholastic, creative and innovative capabilities of the university, as well as to facilitate and manage research and development. To complete the teaching and learning activities at UITM, the university has made available modern and contemporary facilities such as the UITM Stadium, the house of UITM FC. With a capacity of 6,000, the stadium is the heart of soccer and it has played host to an international match in 2009. UITM also has an Olympic-sized swimming pool for the use of students and staff. The pool is also open to public on certain days. Built in 1972, Perpustakaan Tun Abdul Razak, or the Pita Library, has grown by leaps and bounds, housing thousands of international titles for all programs of study. Students' participation in extracurricular activities is highly encouraged and supported by the university. These activities would not only equip students with soft skills, but also train them to be balanced and holistic individuals to meet global requirements. As the largest public university in Malaysia, University Technology Mara has produced thousands of alumni who are successful individuals in their disciplines. They are award winners, innovators, entrepreneurs, and leaders in both the government and private sectors. UITM honors its alumni by engaging them to establish smart partnerships resulting in strategic alliances. The alumni also gives back in areas such as academic improvements, charity work, and fundraising. University Technology Mara, Usaha Takwa Mulia.
I studied here since diploma until my degree. Actually, at first, I thought that when I took accounting, I thought it's gonna be in Uniten Bangi. But end up, it is at Uniten Isamsr. This place is so quiet, so peaceful, and I love the environment here. So every time I woke up, after I'm taking bath, I'm gonna took like 10 minutes to pick my clothes. I'm going to do my makeup, and then I go to class every morning. After class in the evening, I'm going to maybe a gym, or I'm going to the study group in library, or hang out in any cafe that I have here. There's a lot of activities that we have here, which is badminton, wall climbing, and we can also go to jungle trekking and hiking. So I used to go to Kuantan. There's so much place that we can go. To me, Unitan is a retreat.
For 60 years, University Technology Mara, or UITM, has been the place for acquiring knowledge and developing capabilities. From a training center to now a vast network of universities, UITM has campuses and faculties all over Malaysia. UITM allows for the pursuing of goals and earning a degree in any field of choice, with a mission to enhance the knowledge and expertise of Bumiputras in all fields of study, through professional programs, research work and community service, while upholding moral values and professional ethics. Nestled amidst the greenery and some of the most scenic areas in the country, each university campus is strategically located in places where their presence inevitably provides an economic boost to the local community. UITM pledges to provide maximum opportunities to pursue professionally recognized programs of study in science, technology, industry, business, arts and humanities. University Technology Mara offers quality education at all levels of study, from foundation to postgraduate. The university has always been at the forefront in science and technology, as well as in management. It is a place where talent, skills and excellence are nurtured. UITM has a mission to empower the indigenous people through the provision of higher education in accordance with Article 153 of the Malaysian Federal Constitution and Act 173 University Technology Mara Act 1976. Duli Yang Maha Mulia, Sri Paduka Baginda Yang di-Pertuan Agong is the Chancellor of UITM by virtue of his status as the King, as provided for by the law. UITM has established 8 centers of excellence and 1 high COE to enhance the scholastic, creative and innovative capabilities of the university, as well as to facilitate and manage research and development. To complete the teaching and learning activities at UITM, the university has made available modern and contemporary facilities such as the UITM Stadium, the house of UITM FC. With a capacity of 6,000, the stadium is the heart of soccer and it has played host to an international match in 2009. UITM also has an Olympic-sized swimming pool for the use of students and staff. The pool is also open to public on certain days. Built in 1972, Perpustakaan Tun Abdul Razak, or the Pita Library, has grown by leaps and bounds, housing thousands of international titles for all programs of study. Students' participation in extracurricular activities is highly encouraged and supported by the university. These activities would not only equip students with soft skills, but also train them to be balanced and holistic individuals to meet global requirements. As the largest public university in Malaysia, University Technology Mara has produced thousands of alumni who are successful individuals in their disciplines. They are award winners, innovators, entrepreneurs, and leaders in both the government and private sectors. UITM honors its alumni by engaging them to establish smart partnerships resulting in strategic alliances. The alumni also gives back in areas such as academic improvements, charity work, and fundraising. University Technology Mara, Usaha Takwa Mulia.
Assalamualaikum and very good afternoon to all. It is a pleasure to welcome all of you to the presentation sessions number 2 of the 4th International Symposium on Agents, Multi-Agent and Robotics, or known as Isamsr 2021. So since we are still in pandemic era, the session is done virtually as part of the new norm that we are embracing now. Before we start, please make yourself as comfortable as possible to listen to our speakers who will present their and share their research as well as their research findings in a live presentation and also video presentation. The track of this second session is Internet of Things or IoT. We will have 5 presenters from 5 different institutions, and they are all from 3 different countries, namely Malaysia, Iraq, and also Bangladesh. Let's start and enjoy the session, shall we? Okay, I would like to welcome the first presenter, Dr. Sharinas Ismail, with the research entitled Agent Mediation in RADT Framework for Self-Quarantine Monitoring. Dr. Sharinas is from University Malaysia of Computer Science and Engineering, or known as UNIMAI. Let's welcome Dr. Sharinas and let's listen to her presentation. Please.
Screen. Okay. Hello, everyone. I hope you can see me here. Okay, am I on? Sorry. Okay, my name is Sharinas Ismail. I'm from UniKL. And this is the project by my student in UniKL before I left UniKL. I am now in UNIMAI. And along with me is the co-author Dr. Husna Sarira. And my student is actually Hazwan Masuki. And the title for today is Agent Mediation in RADT Framework for Self-Quarantine Monitoring. So we are looking at software agent in IoT. All right. Okay, let me begin. Okay, as for in the introduction, the advancement in knowledge is put to a huge challenge ever since the start of the pandemic in 2019, in which that we have vast of information and knowledge need to be churned, need to be monitored, need to be known and made known to everyone. And it's like a daily basis, even like hour basis and all. And it has been a challenge for in the field of medical, in terms of medical, pharmaceutical, even in for society, information management, etc. And countermeasures has been are needed, and the countermeasures has been done for during the pandemic to actually make the information known to everyone to reduce the spread of infection. Among all is the mandatory quarantine after the travel for those who go abroad overseas and come back, and also for self-quarantine at home. So these are the two things that are common during the pandemic, which we have experienced and anywhere we go, right? And the challenges of self-quarantine that we have today is being highly depending on human factors, individuals' conscience, in which that everyone has their own self-discipline, whether they want to quarantine themselves, they want to be diligent in quarantine themselves or believe in quarantine itself. And also there are challenges in terms of monitoring issues, in terms of, let me try to move this. Yeah, sorry, I can't even see my own slide. In terms of compliance rate for the self-quarantine, the clusters and the pink Bengal viral news. There's a lot of viral news regarding people being out there instead of being quarantined, etc. And of course, the time on the side of our health officers to monitor everyone is it's really, really challenging because they cannot spend too much time monitoring everyone, right? And from there, there is an area of self-quarantine monitoring, which by chance we have it, but not really clear. And there are actually things that we monitor closely, which we started off with body temperature and other health status and condition after that. But body temperature becomes the main thing that triggers, or the first thing that we measure every day or everywhere that we go. And this actually brings an opportunity for monitoring purpose, and in which that the devices and technologies are available. Data synchronization with mobile apps are there, and small size devices with enhanced usability are there. We we now have wearable devices and all, and these wearable devices are linked to has its own built-in Bluetooth and Wi-Fi, and of course we have the IoT technology itself. So what we are proposing here is based on the questions that we have in mind, how to manage knowledge in monitoring the self-quarantine individuals for everybody's benefit, and how multiple readings of data be processed to generate knowledge for useful findings and alerts, not just for the medical officers, but for everyone who can get the benefit out of it, right? So the proposition is to apply the personal knowledge management concept in technology, in which I will explain in detail here. Okay. All right. So, introduction-wise, this research proposes a mediation of software technology, agent technology in framework developed for self-quarantine monitoring. Actually, we call it RADT, a multi-agent RADT framework for quarantine monitoring system to facilitate work of the health officers in ensuring that the quarantine individuals adhere to the regulations, as well as being alert on the changes in behavior patterns of the individuals in terms of health and movement. So in other words, we are looking at how to actually have a guideline or a framework that can, advise us later on how to implement the software agents in terms of retrieving knowledge and sharing it to the right people. Okay, so among the related works that I highlight here, I won't read all because we only have like a limited time here. There are two parts for this paper. One is the self-quarantine monitoring, which there are a lot of papers out there, especially in 2020 and 2021. And another part will be on software agent. Due to the danger of COVID-19 pandemic in 2019, three social alterations were suggested by Supawitaya in 2020 and his friends. Number one is social distancing, which are very familiar of, in which we have to take guard off when we go for, go to public spaces and all. Self-quarantine, which consists of periodic, which consists of individuals being temporarily being at home or being a place not socializing with anyone at all for a period of time. It used to be 14 days. Now I heard it's 10 days. I'm not sure. As for me, I just stay at home. Self-isolation, which is actually for the infected people who must keep away from the public. I get to know that self-quarantine and self-isolation may be similar, maybe not, depending on the country. Some place they call it self-isolation, some place they call it self-quarantine. So I believe that what we are going through for this paper is more on self-quarantine, in which we focus on home quarantine or probably hotel quarantine, which is not hospital. Right, that means. So in many countries, individuals returned from traveling abroad. They are obliged for the 14-day self-quarantine, monitored by a contact tracing mobile phone. They also have phone call twice a day with random personal visit. A lot of work to be done there. And this is by Kim 2020 and Lee 2021, who reported this incident being implemented in South Korea. And from the South Korea experience, there are actually, initially, there were no evidence on measuring the exact non-compliance rate of self-quarantine. And various methods of data collection has been done, both manually and automatically. And addition of data extraction method of block entry with web crawling, manual checking, they have done a lot. And when you talk about web crawling and all, it already goes beyond whereby, I don't know, probably the breach of privacy and confidentiality of data might be in question. All right. So a smarter and autonomous way of monitoring is yet to be reported. This was as per when we investigated the literature review. Okay, I did not check yesterday's literature, so don't ask me about that. Okay, drawback is the last part. So the big data from individuals using activity trackers can also be used, and there's something called Wistings. I'm not sure which country this is. I believe it's somewhere in Europe. They analyze to counter the wearer's average daily number of steps. Sorry about the misspelling there. It's actually steps, number of steps taken, footsteps, yeah, based on the restriction mode. So it's not really specific to self-quarantine, but the technology is there. That's what it's trying to highlight. But then again, what about those people who does not own any mobile, smartwatch or mobile device that can calculate the steps or pedometer in that word. All right, so it's kind of like not so not so fair to them, right? Okay, there's one country, Slovakia, that individuals are allowed to be isolated at home. They must install a mobile app. So this is actually I believe it's the ruling by the government that whereby they have to install the mobile app with random facial recognition check and tracking. So that's the initiative done in Slovakia. But in general, I have here Australia, Singapore, South Korea, and Taiwan. They have mobile apps, location-based drones, video calls, closed-circuit television, even daily monitoring calls. They have all of these self-quarantine monitoring activities going on, not just the normal, what you call it, the normal medical tracking that doctors normally have, right? So on the side of the related work with regards to the technology, I look at the knowledge management within the multi-agent roles. The knowledge representation and reasoning in AI field has become quite an interesting aspect, and it has been. It has been my interest for the past how many years, and knowledge management and granularity of intelligence has been looked into. We have looked into that area in terms of personal knowledge management concept in AI, agent design, and software agents and their assigned roles in agent environment also falls in this field. So in other words, we are looking at how to model the agent using the concept of knowledge management. And when I say that, I did not mean the normal knowledge management under AI field, but it also involves the knowledge management concept from the social science. I'm actually a hybrid, so I look at both aspects. And software agents, learning new knowledge through processes based on how individuals manage knowledge. That's what the previous paper has mentioned. And they came up with this particular model called GUSC, which is get knowledge, you understand knowledge, share knowledge, and connect knowledge, which was derived from exhaustive literature reviews by previous authors, including Matt Farlane, Jacques Eric Marita and team, which includes Kirchner and Susina, Grant Jenkins, Latinati. I know they are quite old, but they are the ones who actually link with, knowledge management, personal knowledge management, and technology, which is, after some time, it kind of like fade away, but it's still there. It's just that people might not coin them as personal knowledge management anymore. Okay, application of GSA is supported by the capabilities of software agents, employing knowledge or representation of the user's goals and desires as well. It's not just something that we just simply want to do, but it actually based on certain drive that we have. Everything goes back to AI. So the concept was expanded to cognitive enablers. Sorry again for the typo there. Which include method, identify, decide, and drive. These are the four enablers that we believe to, they have to be there to support the personal knowledge management processes. And by having that, we can actually, not to say play around, but we can actually identify the roles of the agents much more better. So enablers of these four are adopted to be the main task and that makes multi-agent system workable. After 2012, we managed to expand that into the task of the software agent and go into deep for the multi-agent roles. So the previous work based on this has been expanded for agent mediation, for smart notification, for smart classroom management. We even went into geriatric health monitoring, which we came up with quite a few frameworks, including detection, prediction, action, DPA. Okay, and these are all between 2013 to 2019. Okay, hold on. Okay, so in terms of methodology, these are basically what we would like to propose. We start off with a case identification and then knowledge identification, and both of these will be embarked or will be onboarded to the data elements identification for vector data rigging, and then we produce the framework. Please bear in mind that this is just a conceptual paper in which that the validation, the implementation, the development, even the algorithm and all will be our future work. All right. So this one is like a very, very rough idea what we want to do next. Okay. So for case identification, for self-quarantine case, we understood that there are two vital data required, which are actually the body temperature and the movement. What I meant here by movement is actually the location or the position of that person, whether they are that that person in quarantine, whether he or she, sorry about that, he or she is in the place that he was supposed to be, right? So meaning that if the registered place that they are supposed to quarantine is at home, the address of the home, therefore they should be at home, not somewhere else for 14 days. And that's basically the idea, lah, right? And so let me go into the two vital data. One is body temperature. Everybody knows that, and it is expected that every day we take our own temperature if we are under quarantine. And there are other three or four more vital signs that are very common in paramedic. And I had this presented in my paper in 2019, which I just extract part of it, which is only the body temperature, into this paper. And the other three is actually the common ones are pulse rate, respiration, and blood pressure. There is another one which is not so common, but whatever it is, it's not included here. But if you are interested to extend this, you can actually add more depending on your purpose and as well as the budget to implement it, right? Movement here, how are we going to tackle movement? How are we going to know whether that person is within the range or not? So it's actually a vital data due to the cases of individuals being out and about in public when they are supposed to be at home. To detect whether the person is outside certain radius of the home, we need the geographical coordinate, longitude and latitude values. Normally, the device will capture the raw data, which is only these two data, and by right, our system need to be intelligent enough to know where is the location based on these two data. So capture of raw data of the coordinate will, then be translated into GPS by the system. Into geographical position by the system compared with the location of the registered home that is registered when they started the quarantine. So I'll try to be quick here because I keep on hearing some ding ding just now. Okay, so knowledge required for software agent tasks. I've already broken it down into what, when, how, and the alert itself. So what we've already covered just now, body temperature and movement or position. When will be the suggested time to retrieve the data? So based on this table, we can see that normally this is actually from literature. It's not my creation. I read it through John Hopkins Medicine and a few other medical reports as well. And they say that in the morning, in the evening, and then some, during certain time during the day. And if the first time you take the temperature is like quite high or borderline or something like that, or very low or borderline something like that, then you might want to take again, not too late after that, meaning like after 15 minutes or after 30 minutes or things like that. So in other words, when taking the blood, the body temperature, it has to be depending on the situation of that particular person, real time. So that's why we need agent to actually be smart about it and know when to take the next data. Okay, so the link is there. You can go and check my paper later. How? Method of analyzing the data with calculations. There are, I think the notes are all here, how to actually know the range. Okay, so below the normal low is 35.5, the normal high is 37 Celsius, I think, yeah. And single measurement fever is above 37.5. This is just for the COVID-19 pandemic case. For the previous paper that I had more ranges, more variables there. I had one for very low temperature, hypo, if I'm not mistaken, and very high, things like that. So, yeah, a range depending on the situation. But for our case here, we are going to check only those above 37.5. I didn't add here on the dot 37.5, but yeah, probably this can be input later if you feel that it needs more improvement. And the fourth item here is alert. The rules to activate the trigger to alert or notify the health officer and or the guardians. The guardian here means the individuals who are close to that person, a family member or a best friend or things like that, or somebody like that who do not stay with the person. Okay, so agent with data retrieval task will refer to the when information here and capture the reading, and then more than one data to make sense of the result. So again, the data is not just one. When we retrieve the data, we have to look at multiple data at one go and analyze. When I say we, I mean that's what we need to get the agent to do. So once understood, the information is passed to the next agent to decide what to do, to alert, and so on and so forth.
Excuse me,
Okay,
Dr. Nas, can you just resume your presentation, please? Thanks.
resume. Oh,
Sorry.
summarize, is
Yes.
it? Oh, okay. I'm too long again. Okay. Let me go straight to the framework. So the framework basically have four agents: retrieve agent, analyze, decide, and transmit. In which that retrieve will retrieve all the raw data, and the analyze agent will actually look into how frequent should you take the temperature and the movement, and what could be the result, and it will pass down to the decide agent to decide whether it's green alert, yellow alert, or red alert. Red alert, if it's red alert, it will check with the profile setting and transmit to the transmit agent, and transmit agent will check with the profile setting what is the preferred channel to send the alert. If it's red, send the alert. If it's yellow, or if it's green, where should it report to? Is it just an app or a website or things like that? So basically, the idea is to have these four agents, which is called RADT, retrieve, analyze, decide, and transmit, in which that we are looking at how to implement it in hardware. And I don't cover this on hardware. I don't cover hardware in this paper, which it is actually a very huge room for improvement for you guys. If you want to take up this project, let me know. We can discuss further because I really want to implement it and I want to look at the knowledge base system at the back end. Yeah. And just to add a little bit more, it actually have a room for improvement in terms of the duration of the lifespan of the agent. If by chance there are anyone there whom you know that you can refer me to, who does the suicide, I call it suicide agent, who can self-terminate after 14 days or 10 days, depending on the requirement of the system, let me know because it will be an interesting part in which that we only require the agent to work only for a temporary time, and if it's cheap enough we can make it a disposable hardware. Okay, I think that's it that I want to highlight here. Thank you very much, and yeah, thank you everyone and the organizer for this particular conference. Thank you.
Thank you very much, Dr. Sainas. This is very interesting research. And yeah, sorry for the time limitation that we have. I believe it is very interesting and it can be explored further, your research. And I also hope that we can benefit from it, especially in this COVID pandemic era, which involve process of quarantine, as you mentioned just now. Okay, great. Let's move to the second presenter. So let's welcome our second presenter today, Dr. Farah Wahida Muhammad from University Kuala Lumpur, UniKL, with the research entitled Hello Doctor, Mobile Applications. So let's listen from Dr. Farah Wahida, please.
Okay. Right. Can you hear me? All right. Okay. Assalamualaikum and a very good evening to all of you. Okay. My name is Dr. Farah Wahida Muhammad. So my paper titled Hello Doctor, Mobile Application is more on a prototype application. Okay, which I think if we compare it to a previous presenter, is more on the conceptual or maybe more on theory on the IoT and everything. But my paper is more on developing a prototype and application which could help in our pandemic, in the COVID-19 pandemic. So in this paper, Hello Doctor mobile application, well actually I put it under infographic poster, but don't worry, I will highlight things that for you to look at. Okay, so before we proceed, I would like to share with you why we need this kind of application. maybe during our last Vision 2020 is one of the flagship is developing a telehealth medical okay for our citizen. So by having this kind of idea, okay, me and my student, okay, try to develop an application, okay, which we call it as a Hello Doctor mobile application, which to help, especially in this COVID-19 pandemic. So we can see from here the problem statement where the patient always does not have time to go to the clinic or hospital to get treatment. We can say that most of us nowadays sometimes we are very frightened, okay, and we are not so feel not secure to go to the hospital or clinic, and people are afraid to go to the clinic since it will harm their health. Okay, that's the what we call as they assume, okay, especially during this COVID-19 pandemic. So most of them willing choose to meet up with doctor privately because it's obviously can eliminate the risk of COVID-19. So if there's tools or I think application that could assist patient or maybe the people who sick, okay, in order to interact with the doctor, okay, contactlessly, okay, so maybe this application could help to solve their problem. So another problem that we found is unsystematically scheduled among doctors and patients always happen, okay, and this contribute to missing appointment. So sometimes, especially during this COVID-19 pandemic, when the doctors cancel the appointment, so it will be something like we don't want that, okay, during this COVID-19 pandemic. So how we want to solve this problem? So based on this problem statement that we highlighted here, so we can see that there's a need, okay, so our paper objective is to analyze the problems why patients keep afraid to come to the clinic since Malaysia faced to pandemic COVID-19. And our second objective is to develop an application that can allow patient to book doctor for consultation. Nowadays, even if you want to make a transaction in bank or maybe if you want to go to dine in any restaurant, for example, they still need you to, they still want to see your vaccine certificate, right? So how we want to cater this kind of problem if you are sick. So we can see that this application could help the doctors and also the patient in order to book the appointments. And our last objective is to test this prototype whether it can be accessible, okay, it can be used by the doctor and also by the patient by using this application. Okay, in this application, okay, our scope is we propose those requirements, for example, the appointment, and then the doctor can, you can select your own doctor, for example, and then you also can, the doctor can order the medicine and send to your home. So that will be scope of this application. Okay, and for this case, because this is just a prototype application, so this application has been tested to the patient and doctors around Seri Kembangan, Selangor, where we put it as a our testing respondent is from Seri Kembangan, Selangor. Right. So I could say that this is the research methodology, which is the methods that we use in order to develop the prototype. Okay, we are using the rapid application development, where there are four phases in this application. In this method, which is we have requirements planning, we have design prototype, we have construction and training, testing, and also cut over. So in each of these phases, we need to, for example, requirement planning. We need to understand what's the requirement from the doctor, what's the requirements from the patient itself, okay, the user, and maybe the not only the doctor, the officer that will handle this application. Okay, and then from the user design prototype, this prototype is to work to show off specific features with a good for polish. And for the construction and testing, the test should be limited to just pure functionality, but also visual interface. Because this is just a prototype, it's more on we are looking on the user acceptance on how this prototype will work on with the patient and also the doctors. Right. So this is prototype, and after this, I will share with you the video of the product of the application. So it could maybe highlight certain, certain good things, okay, regarding this application, okay, especially during this COVID-19 pandemic. Right, so this is the interface of some of the interface from the application. So it will start with the welcome to the page, okay, which is you can access via patient or doctor, okay, and then from the there's interface for the admin, interface for the patient, and interface for the doctor. So the admin will administer okay, any setting or any database involved, and maybe the adding, maybe there's a few flaws and here and there. So admin will solve that problem. And for the Hello Patient interface, this is the registration page for a patient, okay, to register themselves, and in order to do the payments, okay, and then by having this kind of application, they also can collect point, okay. So yeah, nowadays when we talk about the e-wallets or maybe mobile application, things that might trigger or might be the best thing about the application is we can have a point, okay, by installing them or by using that application, so we can accumulate our points. So maybe it can convert to the cash, or maybe could be like that, right? Right. And then that's for the interface for the Hello Patient here. And they also interface for the Hello Doctor, so where the doctor also can assess the application from the patient. Okay, for example, the patient already stated what's he feel. For example, his fever is 38 and above, so it's 6, right? Okay, and then maybe and the patient also stated what are the things that he feel. For example, there will be a chirit berit, for example, okay. So it was stated that. So from that statement, okay, the doctor itself will diagnose, okay, will diagnose based on the statement from the patient, and the doctor will at this point, maybe it can offer the medicine, okay, to the patient, and the medicine can be sent to the patient via Grab service, so or maybe Lala Move or etc. So this is what we can say that by having this kind of application, we integrate, okay, all others application too. For example, we integrate with the courier services, or maybe Grab, Boost, or Lala Move, and etc. And by having that also, it could assist and could give a benefit to the user and to the doctor. And how to self-diagnose, okay, because sometimes we want to make sure that the person or the patient itself, they are doing or they are choosing the right diagnose for themselves, right? Self-diagnose. So this is this page, or maybe there's an interface that the patient need to self-diagnose themselves. Okay, for example, giving how many range of he feel of pain, okay, and then what's the some of the simple question. Okay, so they must answer those questions first. Okay, and then there's an interface for the delivery option and etc. Okay, so so before I go, so I would like to share with you the video, okay, about the application. Okay, just hold a moment, yeah. Okay. Okay, so okay, right. So this is the interface for the admin. Okay, so admin will log in. Okay, and it can also register for the list of doctor. Can see the list of doctor. They can also delete the list of the doctor also. And they also can see the list of the patient. Okay, then they can see the history of redemption because I stated about the point just now, right? So they also can register new clinic nearby. Okay, for example, in this area is Sri Kembangan. So there's another clinic. So they register clinic Aiman Maju. Okay, for example, okay, in the system. So this is falls under the admin screen. And also they need to key in the phone number of the clinic and also the address. Okay, so you can see that clinic Aiman Maju is already in the system, in the application. Okay, so we look into the patient interface. Okay, so yeah, first of all, they need to register themselves. Okay, once they are registered, so they can log in. Okay. And also they can edit their profile, maybe during the registration they maybe miss incorrect information, so they can update their information. Okay, so they can update. Okay, for example, he has a sick, so he need to self-diagnose first. Okay, he put temperature 38, for example. And the pain scale here is you can change worst pain. Okay, you can choose from the scroll text, and then you can also put symptoms. Okay, and they can book to the doctors. Okay, so there's a two available doctor here. Okay, so they also can select date. Okay, and time. Okay, so book calendar confirm. Okay, so it's pending. So it need he need approval from the doctor. Okay, so the doctor will, okay, before proceed, they can make also payment here. Okay, so this is the interface for the doctor. Okay, same, doctor also can log in. Okay, so the doctor also need to log in. Okay, doctor also after log in, it can doctor can also update their profile. Okay, this is the best thing where when they put patient, they click the patient button. Okay, so so you notice that there's a notification, there's a application from the patient stated that what's his specific sakit semua. Okay, so you try to diagnose and put, for example, there's a urea tadi kan, diarrhea. So there will be a suggestion from the doctor to give the PCM 10 tabs. Okay, this is one of the medicine for the diarrhea. And also another medicine such as loratadine, 10 steps BD. Okay, and this one the doctor will okay, the list clinic certainly that use that, and the doctor can assign any pharmacy or clinic to send the medicine to the patient. Okay, by using Grab or Lalamove that I mentioned just now. Okay, and doctor also can see any history of what he has done so far by using these apps. Right, the doctor also can collect points. Okay, so this is the account number. The doctor can give the account number to the patient, okay, and request them to make payment. All right, okay. Okay, that's some of I mean the video of the project of the application. Okay, let me share again the screen. Okay, so as a conclusion, I could say that by having this kind of application, such as the Hello Doctor application, is one of the new development to make accessible all the patient to get the consultation. There is an excellent need for thorough evaluation, validation and development of best practice standard for medical application to ensure a basic level of quality and safety. Maybe I could say that MIIT, for example, we can collaborate with RCMP, for example, and to come up with validation whether this kind of application can be used, okay, because when it relates with the medical things, okay, so I think the issues of security and also the issues of security is very important here. Okay, so with the implementation of such measures, the primary determinant of an application value may ultimately be its ability to provide meaningful, accurate, and timely information and guidance to the end user to serve vital purpose of improving patient outcome. So by that, I think that's all my presentation. I do hope that this application, because I'm in the process of applying a grant for this application. So I do hope that from this presentation, it could be maybe you can give some suggestion or maybe a recommendation for us to do this project better. Thank you. Assalamualaikum.
Okay, thank you for the very interesting research on mobile applications, Dr. Farah Wahida. So he hope he can get benefit from it since mobile applications are everywhere now, as we know. Presentations. The author is Mr. Tung Chun On and Dr. Naif Al-Duais from Faculty of Science, Computer and Technology Malumat, University Technology Tun Hussein on Malaysia, with the research entitled IoT-based contactless body temperature scanning system for a smart and safe campus. So let's listen to the video presentation, shall we?
In this video, I'm going to present the paper, and the title is IoT-based contactless body temperature scanning system for a smart and safe campus. These are the outline that will be discussed in this video. Let me start with some general information on Internet of Things. IoT is the technology device with sensors, software, and other technologies which can connect and exchange data with other devices and systems over the Internet. IoT has evolved in many fields such as domestic, industrial, environmental, military, biometric, transport, etc. Due to the outbreak of coronavirus disease, checking body temperature and recording personal details have become the new norm. Everyone requires to follow this standard operating procedure when arrive a new place. However, there are some problems occur when conducting this SOP. So, an IoT-based contactless body temperature scanning system is proposed in this paper to avoid the problems occurring in UTHM campus. There are 4 problems occurred when conducting the SOPs. Firstly, there is a close range between the worker and customer during the measurement of body temperature. So, they could be infected if one of them is a virus carrier. Secondly, checking body temperature and writing the personal details of customer are not able to conduct instantly. Although MySejahtera application was developed to enable people to record their data by scanning QR code, many people complain that the application is unresponsive and keep crashing. Next, the recorded data will be lost as the information of customer is recorded into a logbook. It is possible to be lost due to some reasons such as forgetting to take it back and being taken by an outsider. Lastly, the recorded data is not real or incomplete. Some customers rush and think that writing the details are wasting their time, so they just write down their name in short form or leave it blank. The IoT-based contactless body temperature scanning system was developed to ensure UTHM campus is safe and reduce the risk of spreading the virus. It allows users to measure their body temperature and record their personal details without involving other people. Meanwhile, human resources can be reduced as no worker is needed to check people's body temperature. Moreover, users can upload their personal details without using a mobile phone, as only an identity card is required. Lastly, the recorded data is saved into cloud storage, so the users and admin can check the previous recorded data through the monitoring website. Table 1 shows the summary of characteristics of some related works. From this table can analyze that the proposed system is better than the 3 existing systems due to some reasons. Firstly, an identity card scanner was designed to replace the face detection, as users can record their personal details by scanning their identity card. Next, human resources can be reduced as no worker is needed to check people's body temperature. After that, the proposed system was not as complex as the 3 existing systems, so the checking process was fast and there will be no problem on the accuracy of body temperature measurement. Lastly, the proposed system also can be used as an attendance system, as users required to check in and check out. Figure on the left is the use case diagram of the proposed system. There are 2 actors involved in this system, which are user and admin. Moreover, the functions of the system are listed, which are login, register, edit profile, check body temperature, scan personal details, view reports, update database, and delete account. While figure on the right is the activity diagram of the proposed system. From the beginning, the user has to scan his RFID card, which is an identity card of the user. If the scanning system does not detect the ID of the card, then the user is required to scan the card again. Once the ID of the card is detected, the user needs to check body temperature by closing his forehead to the contactless body temperature sensor. If the body temperature is between 36.1 degrees Celsius to 37.5 degrees Celsius, then the scanning system will emit a green light and a short beep sound. Otherwise, the scanning system will emit a red light and a long beep sound. After that, the data is recorded to the cloud storage. Finally, the body temperature and personal details of the user are displayed on the LCD screen. Next, figure on the left is the wiring diagram that shows the physical connections between the IoT components in the prototype. 6 components are included in the figure, which are Arduino Uno, RFID module, contactless body temperature sensor, LCD, buzzer, and LEDs. The connections between the components are shown by using different colors of line. And the figure on the right shows the hardware setup of the contactless body temperature scanner. Now, I will show the demo for the prototype of IoT-based contactless body temperature scanner. Hi, welcome to my system demo video. Now, I'm going to present how the contactless body temperature scanner is worked. Once the hardware is on, the LCD shows a message to notice the user to scan his identity card. When the scanning is success, the RFID number is displayed and the body temperature checking is done. When the checking is done, the value and the status of the body temperature are displayed and the LED is light out. Then, the recorded data will be sent to the cloud database. Next, I'm going to present the monitoring website of the system. User is required to log in this monitoring website by using his user ID and password. If the user does not have an account, then he can register an account on the sign up page. In this sign up page, user need to fill this registration form to create an account. Once the registration is success, then he will be redirected to the homepage of the website. From the homepage, user details are displayed in table form. If user wants to edit his profile, he can click on the edit button to update his personal information. Once the update is success, the user details are updated. Then user can view the previous record by clicking on the report tab on the navigation bar, and the recorded data is shown. For admin, he also can log in to the monitoring website by inserting his ID and password. Once the login is success, admin will be redirected to the admin dashboard. Next, admin can view all the recorded data in this website. Admin also can perform CRUD action, which are create, update and delete action within this website. For example, by clicking on the Create tab, admin can make a new report by inserting the information. Admin also can edit the data by clicking on the pen icon. If admin wants to delete certain data, he can click on the trash icon to delete the selected data. The bar chart illustrates the result of user acceptance testing for IoT-based contactless body temperature scanning system. 4 participants were found in the Parit Raja area to do the testing and provide feedback for the developed system. Based on the bar chart, all the respondents were satisfied with all the aspects of the developed system. However, 2 respondents gave average feedback on the acceptance requirement number 4, which was the system is able to admit light and sound. Moreover, there were no respondents found not satisfied with the acceptance requirements on the developed system. For the accuracy testing, it was conducted to compare the accuracy between the developed system and standard device. Table 2 shows the result of accuracy testing for the developed system. Based on the average accuracy for all the experiments, the temperature values of the standard device were slightly different, as the same device was used for these 5 experiments. For the proposed system, the temperature values were different in the experiments, but almost the same with the temperature values of the standard device. Therefore, the accuracy of the proposed system was roughly the same as the standard device. In conclusion, this paper proposes an IoT-based contactless body temperature scanning system for a smart and safe campus. The proposed system helps users to measure their body temperature and record their details without interaction with other people. The proposed system was successfully implemented and ready to be deployed. The average accuracy of the proposed system was 99.86% compared to a standard device. In the future, the system will need to be improved in terms of the time it takes to upload data to the cloud and the implementation of additional features to the monitoring website. Lastly, the authors would like to express their thanks to University Tun Hussein All Malaysia for support. This research is supported by University Tun Hussein All Malaysia through Tier 1. And these are the references for this paper. That's all from me. Thank you for watching this video.
Thank you. So thank you is for then this is very interesting research. So let's proceed to the fourth presentations. It will also be a video presentations. The author is Mr. Ms. Wala Hussein from Iraq University College, Iraq, with the research entitled Implementations of Washing Machine System via Utilization of Fuzzy Logic Algorithms. So let's listen to their video presentation.
Hi, Salam. Good afternoon to all of you. My name is Kamil Karim. I will be the presenter for the project for the paper of implementation of washing machine system via utilization of fuzzy logic algorithm. I have already submitted this paper to Ismar IEEE format. This project was prepared by me, Kamil Audakarim, and my friend Wala Hussein Ali. Here we have the introduction. The first fuzzy logic was considered in 1965 by Professor Lutfi Zada, University of California, Berkeley. The reason of using the fuzzy logic is to monitor nonlinear system, which is considered as the complicated to do it mathematically. And of course, by applying fuzzy logic and fuzzy set theory to uncertainties and non-probability can be monitored, fuzzy logic presents a different way to come up to a control of categorization issue. This paper chose a washing machine as a purpose on fuzzy logic tools. Washing machine is very important aspect in every home nowadays. And in order to have a washing machine that's professionally controlled, that wash time, washing speed, and more, which is very important. Here we have the problem statement, which is summarize this problems that come up with this paper. Fuzzy logic washing machines are gaining a popularity. These machines offer the advantage of performance, productivity, simplicity, and productivity, and less cost centers. Sensors continually monitor varying conditions inside the machine and accordingly adjust operation for the best washing result. As there is no stand for fuzzy logic, different machine performs in different manners. Typically, fuzzy logic controls the washing process, water intake, water temperature, wash time, rinse performance, and spin speed. This is optimize the lifespan of washing machine. More sophisticated machines weight the load so you cannot overload the washing machine. As advice on this required amount of detergent, assess the cloth material type and water hardness, and of course, and check whether the detergent is in powder or liquid form to minimize the running cost. And also we have energy saving features. These consume less power and are worth paying extra for if you wash full load more than 3 times a week. Impulse sensor monitor the washing process and make corrections to produce the best washing results. Our objective: by applying a fuzzy logic rule, make it easier to get a cleaner cloth compared to the traditional method of manually adjusting the output parameters. In addition, of course, applying fuzzy logic saves the amount of water, detergent, and electricity, and finally save time, which is a big factor reducing process cost. This project is aimed to design and implement a washing machine system, as well as to study the effect of applying fuzzy logic rules in enhancing washing machine control system, and to apply the proposed project using MATLAB software as well. The MATLAB Fuzzy Logic Toolbox was used to simulate this study. Finally, practically, mechanical and electronic engineering concepts should be used to implement this system, the following system. We have some literature here, and of course this was mentioned in the reference, of course, in the paper. Fuzzy logic is very powerful design concept used to develop. This can be found in reference number 5. Design concept used to develop and describe control system, providing an intuitive and simple way for designing engineers. In order to implementing complex system, fuzzy logic system, inputs can be displayed by changing more than one state at a time, and engineer can naturally describe the system. The two most popular implementations of fuzzy logic are neural networks and role-based. All these fuzzy implementations have a wide range of applications, including security, medicine, avionics, and machine learning, of course. The rules-based system collects expertise. These thought patterns and rules are programmed into the system. Rule-based systems do not require large training sets like neural networks, while the neural networks do not need to specify thinking pattern like rule-based fuzzy logic system, and this can be found in reference number 8. I already used this literature review from all of these references that have been founded in the paper. So what's the difference between these literatures used and comparison between this paper? Compared to this research, this paper depending on the parameters entered in this way. The washing speed, washing time, hot water temperature, and the amount of detergent are applied to the output. Applying the fuzzy logic rules make it easier to get a cleaner cloth compared to the traditional method of manually adjusting the output parameters. In additionally, the application of fuzzy logic saves the amount of water, detergent, and the electricity, and ultimately save time, which is a big factor, and reduce the cost of the process. And this project, as we mentioned before, aimed to design and implement washing machine system as well as studying the effect of applying the rules of fuzzy logic in enhancing the washing machine control system, such as optimizing. Here we have the methodology. According to the following flowchart, we have here to start defining the specification of the antenna design, calculating dimension of the antenna, and of course for the current speed applying the fuzzy logic rules. Compare these results between the calculated fuzzy result, then verifying these data using MATLAB project. Finally, we will get the writing report and reporting the final results. The overall planning and design steps are summarized in the flowchart shown in figure, and therefore this is the concept, the design specification parameters and software. The article concludes with a discussion of the time management and suggest method to show the work plan for this project. And of course, the flowchart shows that there are several steps needed to be done in order to complete the proposed project. First of all, starting with the understanding the basic theoretical of washing machine system and its design using fuzzy logic rule. Generally, the techniques is must chosen probably in order to get a better outcome of the system. Here we go, the design of the data and analysis. We have two types of parameters. For example, we have here the input parameters and the output parameters. For the input parameters, we get the amount of dirt, type of dirt, sensitivity of the cloth, amount of the cloth. And for the output parameters, we get like a washing time, washing speed, amount of detergent, and amount of water, water hotness. All these samples are referring for something. For example, S is for small, M for medium, L for large, and G is not greasy, G for greasy, and more. S for short, long, very long, low, high, very high, etc. All these data, all these samples are representing for something here in data. You can see here as a table, and these data are be collecting as here. For the results, we have a membership function between those data because we have the amount of dirt, we have the types of dirt, and of course we have sensitive of the cloth and the amount of the cloth. So we got here amount of dirt membership function as the following: small, medium, large, and the data as here from 0 to 100 according to the input data that we get from the system of washing machine. Here we go to the less sensitive, normal sensitive, and very high sensitive, according to the sensitivity of the clothes membership function. And of course, according to the outputs, according to the input parameters, we also get the output parameters depending on the data that was entered to the system. So we get here washing time membership function, washing speed membership function, and of course the amount of detergent membership function, amount of water and washing speed between the little, normal, or many, output variable amount of the water. Here we got the result, the relationship between the washing time and the type of dirt, and of course the amount of the clothes. You can see here the washing time from 10 to 90, the amount of the clothes, 0 to 10, and of course 0 to 100, the type of dirt, as the following for the shape. Relationship between the washing time and the type of dirt and the sensitivity of the clothes, as we see in the following shape figure number 2. Relationship between the washing time and the amount of the clothes, and of course the amount of dirt. Here we got the relationship between the washing time and the amount of dirt and sensitivity for the following clothes. As we mentioned before, we have the detergent amount and the sensitivity of the clothes, amount of the clothes. And here we got the relationship between the amount of water and the sensitivity of the clothes, amount of the clothes. For the final result we got here, as in MATLAB following, we got the amount of dirt equal 50, type of dirt, sensitivity of the cloth, amount of the cloth, washing time, washing speed, amount of detergent, and the amount of water hotness. All these data was collected from the input processing to the system using fuzzy logic algorithm. Then we got the final result from MATLAB as we mentioned before. Then we got the conclusion as we have found. This is the art was designed and implemented as washing machine system based on fuzzy logic rules and algorithm. The fuzzy logic algorithm system of washing machine relies on detecting 4 input parameters: the amount of dust, type of dust, sensitivity of fabric and amount of washing, and of course washing speed. Compared with the traditional method of manually adjusting output parameters and applying fuzzy logic rules can make a structure of a cleaner. Finally, we got the main objective of this research paper have been achieved because the application of fuzzy logic can save the amount of water, detergent, and electricity, as well as save the time, which is an important factor in reducing the process cost. Because we are already mentioned in the objective of this project, we say that the project must save the amount of water, detergent, and electricity as well. Of course, we need to saving time, and all these factors must be reducing the cost for the system. So we need to optimize the washing machine system according to the algorithm based on fuzzy logic rules. Here we got some reference, and of course you can refer to the IEEE paper. You can find all the reference are listed there. This is part of these reference which is mentioned in the paper. And of course we have here end for this presentation. Thank you so much for your listening. Hope to see you. Okay guys, thank you so much.
Okay, thank you very much. Um, it's very interesting research focusing on fuzzy logic. So hope we can learn a lot of things from it. Okay, let's move to the fifth and final presentation today. It will also be a video presentation. The author is Mr. Kabir Payal from Bragg University, Mokhali, Dhaka, Bangladesh. His research title is IoT-based cost-effective car parking management for urban area. Let's listen from their video presentation.
Hello everyone, I am Mahmoud from Brecon University, and here you can see our another 5 authors. They are also from Brecon University. Topic of our presentation is IoT-based cost-effective parking management for urban area. And this is our contents we have discussed in our research paper, and we'll try to also discuss briefly short in this presentation also. And in our introduction, we want to say that the number of cars is increasing gradually due to the improvement of technological innovation and the growing population. However, space is not increasing, and situation becomes challenging to manage those vehicles, especially their parking systems. So our system and this paper proposes a concept of the smart parking system in urban areas like Dhaka city, but finding a parking zone is hard enough and time consuming. This parking system uses low-cost technologies so that it can be developed in any urban area with the lowest possible cost in a short period of time. This system will help to make communication between the car owner and the parking areas in real time for finding parking zones easily. The function of communication is based on IoT, which directly connects sensors with a mobile app for data communication. The affordable solution of this paper will help to reduce traffic jams on road and utilize passengers' time properly. In literature review, we have found some research relevant to this, and we have found that in previous research shows different types of designs like introducing web app parking system where a user can choose their preferred unoccupied parking slot from before. Another research has designed the university campus parking lot. It has a web-based application that allows users to have individual account where they can register their vehicles. Furthermore, research shows a parking system to secure the parking slot for disabled people with the help of RFID for verification. The common thing is almost all designs are made with the Arduino-based microcontroller. Our main objective is to ensure more car parking space, help to find parking zone in real time in nearest area, utilizing parking zone with proper communication system, finally minimize the cost as much as possible. While doing research, some questions comes like how does proposed system ensure car parking in real time? How does the system keep track of car occupancy for car owners? How does the system maintain quick responsiveness between car owners and parking areas? How does the proposed system support low energy users as well as minimize cost? So in the whole presentation, I will try to give all the answers of this question. This is our system architecture we have developed for our design, and first one is the car occupancy detection. This setup will be done in the parking lot, and the middle part we have discussed about the try to work on the IoT-based feature where we'll show how sensors will store the data and how they will send and communicate between car and owner. And finally, we have discussed about the mobile app for user attachment to the parking zone. So the first thing is the car occupancy detection. It is important to detect how many parking slots are remaining in parking zone for good user experience. To do that, sensor-based subsystem is developed. Comparing with other papers, this paper proposes to use laser lights and photoresistor despite RFID or ultrasonic sensor-based system for car occupancy detection. This paper also introduces NodeMCU ESP32 for connecting sensors and sending data to online database. Despite Raspberry database, and also we can show that the relevant to Raspberry Pi and Arduino Mega, our NodeMCU ESP32 is low cost and low power and uses low power. This circuit, shown in the right side, the schematic explains the subsystem thoroughly. We can see the ESP32 is the main controller for taking decision. A laser diode is set up on one side of the parking lot and another LDR will be on the other side of the lot. If laser comes to the LDR without any obstacle, it means there is no car in that lot and ESP32 will send data to database that one parking lot is empty. Though we are sharing schematic for one car park detection, we can incorporate more LDR with ESP32 for multiple car slot detection. And the next part is the IoT-based work, actually, how we send the data and how we communicate it, and I will discuss about it here. We have introduced Firebase database, which is great platform for IoT-based work that stores data in JSON object and communicates with the database through API. There is neither server adding problem nor backend database maintaining problem. Firebase platform has tools like a real-time database and its own authentication system which bring advantage for IoT-based work. for registering cars for the smart car parking system and systematically managing those cars in terms of security and flexibility, Firebase authentication is a perfect tool. This tool saves time on building a custom authentication system and works by combining it with databases. Firebase also gives different analytical information using Google Analytics to measure the effectiveness of the mobile app. Using the Firebase application, it will be easy to maintain communication with parking zone and car owners in such a way that parking management authorities will be able to handle factors like which users parked their car in which zone, how much time the car was there, how much bill car owners have to pay for taking service, etc. And the most crucial part of our system is the mobile app design. The mobile app is built with the Flutter programming language. This language is designed by the Google, and this is very much user friendly programming language. Besides, we have designed lots of features on this app. Besides sign up and login pages, there are some features. Now I will describe actually. Our first app feature is finding nearby parking area, which is the home screen of this app. We have connected the app with the Google Maps API, so it can detect nearby location easily. When user opens the app, he will find all parking zones registered nearby. In the first picture of in this slide, you can see that this is the home page, and it is showing that the user can see there are 3 parking lot available nearby. However, the first two has the parking lot, the option for parking, and the third one is actually there is no slot available. And the next feature is slot pre-booking. When the user finds the parking zone with a free parking slot, they need to pre-book it. This feature is added for this purpose. User will be able to see which slots are occupied already by the creative graphical user interface. So he needs to book a free slot using a button named Book Now, which is available in every free slot. So in the second picture of this slide, you can see in the Shantipara Bazar parking zone, there is a 6 parking slot total available. 4 are already occupied with cars. However, 2 are empty, but 1 is pre-booked. And this is shown that this parking lot is booked. However, the last slot is showing book now. That means that there is a 1 parking slot available for booking in the parking lot. And there is also location feature is almost like Google Map location service. However, it shows the direction of parking zone from the current position. If the user books a slot of the parking zone, this parking area direction system is only available in this app location service. And lastly, there is a final feature is the QR code scanning page is required for confirmation of parking. When users scan QR codes using the feature system, will start counting parking time, and it will cause of increasing service charge. The user will only be able to get inside the parking lot if he scans the QR code using this app, and user must need to scan QR code again using the app to stop the timer and see the bill he need to pay. And now we will discuss about the result analysis part. And in the picture showing below, you can see that I told before how car occupancy system works. So it shows that if there is a car, the laser actually try to go through the area, but he cannot pass through it. So the node MCU must send the data to the app that there is a car in this slot, and the second part shows that the parking lot is empty. And so now, in the whole, if we want to briefly discuss about the result analysis part, we can say that from the design prototype, the car parking system, it is observed that the detection of available car parking spaces is indispensable to ensure the working ability of the system. The performance of the detection system exclusively depends on the efficiency of light-dependent sensor as well as on the laser. Moreover, QR code scanning and user attachment through the mobile application play an important role to utilize the book parking system. The QR code scanning ensures the allotment of the parking space for the particular car as long as the mobile application performs as the way of communication between the parking zone authority and car owner or driver. The mobile application also works as the time counter, which facilitates the estimation of the total parking cost and for the particular time. So this is our actually prototype design, and we have simulated in the Flutter development app, and for the showing purpose, we have here run the code as a web view, like web app format. So now I will show you how this thing works actually. So here we can see that there is a 4 car is available and it is updated through the database. And when one car is going outside the lot, and it shows yes, the car slot is empty, and another 2 when the gone, and it shows yes, the 2 car is their slot is empty and 2 is occupied. And 1 car is back, and it is also added in the database, and similar wise all the things are done and updated accordingly. Now we will see that yes, when the car is going outside the space, and see the servo, the door is actually running, the servo runs, and it was shows that yes, the car is here. Now we need to open the door. But however, in our main process, we must need to scan the QR code to get the access. So this is our simulation result we have made in by using the Proteus software. This simulation result actually has done for the showing the voltage and current output result for LDR and LED and laser circuit actually. And this circuit explains our calculation about voltage measurement, and it is theoretically correct. And we try to measure this our calculation according to the tutorial data and documentation of these devices. And now this in left side it is showing that this is our actually prototype design. Actually, this is another demonstration, this image, and and according to the simulation, and we can measure system say that this system is actually cost effective. The power calculated from laser light sensor circuit and maximum power drawn from ESP32 microcontroller servo motor is shown in the table here. It represents how much power this system can consume for parking 10 cars for 18 hours. From this table, we can say that the parking 10 car system consumes 17.56 watt, while drawing its maximum power and cost is 85.23 taka, equivalent to $1. So in future work, we plan to make this system more effective so that the government can make profit from it. We'll add an automatic payment management system so that user can give payment for the service with mobile banking and the government can earn profit from that. We'll also add more features after more research so that the user and environment can be ensured. Besides that, we'll add an image recognition system to recognize car using number plates. And finally, at conclusion, the paper depicts a sustained IoT-based car parking management system that focuses on facilitates uses of available parking spaces, the use of cost-effective equipment such as photoresistor and NodeMC ESP32 has made the management system unique from other available systems, whereas the connectivity of Google Firebase has taken it beyond the boundary. The findings presented in the paper delineate the functionality of the car parking management system, and we are also thinking about the minimize the cost as well as low energy consumption. And this is all the reference we have worked for this presentation. Thank you.
Thank you, and it is very interesting research. So this is the last presentation of today's session number 2. So well, on behalf of Isamsr 2021 team, I would like to extend a great appreciation to all presenters and also participants for this of these symposiums. So we hope that this session will be beneficial to us, especially in enhancing our knowledge and also research in the area related to the theme Internet of Things, IoT. With that, since this is the last session for today, I would like to adjourn the symposium to tomorrow morning, where we will see a number of very interesting keynote speech presented by Malaysian and also international speakers, as well as the paper presentation session number 3 on autonomous system. That's all. Thank you, everyone, and stay safe. Bye-bye.
If you have a mind to upset the status quo with your big ideas for tomorrow's world, then maybe we're just the thing for the genius in you. For starters, every fellow here is brilliant too, hired to rethink how we think and prove that impossible isn't at all. We love their visionary points of view and how their top-tier ideas are helping us to expand what we know and don't know about our world. Working hand in hand, we're out to better the ways energy works for us, to market our inventive ideas and fast-track a world that takes care of us all. Responsible entrepreneurship that will rub off on you. You'll leave our halls of learning wired not just for sensible science, but sustainable business too. A thinker, a breath of fresh air, a game changer, a global visionaire. Primed to keep progress on its toes, the competition on the run, and our planet clean, safe, and secure. But wait. Forget the future for now and focus first on making the choice that will trigger the full potential of you. Enroll. And then, maybe tomorrow, the next big thing that rocks our world will be you.